Good afternoon, everybody. Welcome in the session called EduRoam in the World. We are going to have three presentations coming from different corners of the world. The last one will be coming in by video conference from Tennessee. It's quite funny. I'm looking at the video conferencing room over there and it's still dark, so I hope someone will show up soon enough. But knowing the person, it will be okay. The first speaker of today is going to be Henk Eertink of the Telematica Institute, or Telematics Institute as some might call it. And he is at the Telematica Institute the leader of the group that deals with all kinds of aspects of mobility, basically. And he will tell us some more about the state of affairs of EduRoam in Europe, but specifically also about the new developments and new technologies that we may want to use in EduRoam. Henk, the floor is yours.
Thank you, Klaas. So I'm going to switch to a different presentation. Okay, so this is the result of some joint work that we did with a few colleagues of mine and with Klaas on as a part of Jean 2 work. And today I would like to discuss with you what is EduRoam. So how many of you don't know how EduRoam works? Well, most of you do. That's good. How many of you did already? Oh, okay, good. How many of you do actually use EduRoam? And how many of you do that also outside of their own institution? Okay, that's a reasonable amount. Thanks. So I'm going to talk a little bit about EduRoam and its deployment in Europe, and then I'll go into the EduRoam next generation activities that are part of Jean 2, and we did some testing, mainly with Radsec, which is a new variant of Radiator, and I'll report on that. So EduRoam is really about supporting users that are typically mobile, moving from one university to another, moving towards home, entering public networks, that kind of stuff. So how you actually make sure that you get a secure connection towards the internet, and how do you get a connection at all? I mean, that's the problem of EduRoam. And its internals are, it works on the basis of Radius. This is the current EduRoam. So then you have typically a laptop, an access point that connects to an authenticator. It doesn't work. Okay, thank you. It authenticates to an authenticator, which is typically your access point, which contacts a Radius server, and that goes, if it's not a local user, it goes to some infrastructure Radius server, typically provided by the NRAN. And if that one can authenticate, if it's a national university, it will automatically contact the university nationally, and otherwise it will go to a European or a global authentication server. And your own authentication server will actually authenticate you to any user database of an LDAP, and then get back ultimately to the access point, which will connect the data stream towards the internet or to some other VLAN that might be deployed, and that's based on local policy where to select which VLAN to select. This one? Again, space. Okay. And this gives a nice overview of EduRoam. You see that most European countries have already connected to the authentication infrastructure, and that's rapidly growing. So in the last couple of months, Lithuania, Romania, and Hungary also federated with the central infrastructure, and also Hong Kong did join the federation, and that will be reported also later in this session. But now to EduRoam next generation. You could think, well, this works, so why go into to changing it? Why not keep with the same infrastructure? Well, there are some key improvements that we could achieve in the backbone infrastructure. So you could use, for instance, dynamic trust establishment. One of the key things is that there is a very fixed series of radius proxies that have to be hand configured, and that's not only manual work, but it's also failure proof. There's also some legal stuff. You might need some more formally defined form of federation. That's also being worked on, and I think it's almost okay anyway. But the other thing that we really worked on is on the scalability and the monitoring aspects of the infrastructure. How can you see that the server is failing? How can you make it more scalable to tens or hundreds of countries and multiple institutions in the country? So that means that we need dynamic trust establishment as one of the key issues, and scalability as a second requirement. So that typically in dynamic trust establishment translates to setting up dynamically new connections between authentication servers, so between radius proxies in our sense. So that means that we typically use, we need peer discovery and well, the software of choice, of course, and the service of choice for that is DNS. But we also need trust. So we also need to know whether the party that tries to connect on your network is actually allowed to make use of that network. Otherwise, we could authenticate anybody. So we also need some kind of proof that that user actually belongs to some organizational structure that is connected to, in this case, EduRoam. But in principle, there could be, of course, a lot of roaming agreements or roaming constellations to which your institute belongs. So, for peer discovery and roaming domain participation, we need protocols. I already mentioned those. So for peer discovery, we use DNS. And for confirmation of participation in roaming domains, you need some kind of well-established security infrastructure. So that's either a public key infrastructure, but you might also use a DNS and store information in DNS based on DNSSEC security extensions. So that ends up in, so then you can come into different options for having such a protocol architecture. One is diameter. Diameter is actually a follow-up of the radius protocol that has been standardized by the IETF already a few years ago. And the other one is to extend the well-established base of radius and make that into a peer-to-peer system. So then we need a solution for trust. So one of them is you can use DNSSEC for trust, and the other one is based on PKI, as I said earlier. So these are kind of complicated pictures, but the essence is that we have here on the left bottom, we have your visiting network. On the right bottom, there is the home network, and here is some infrastructure that you might need to establish trust or to locate your server. So the diameter-based architecture would consist of a client on the leftmost part that connects to some radius translation agent that is embedded into a diameter server. And diameter, by design, knows how to discover peer diameter entities. And it does that through DNS, and then uses a TLS connection based on the CA with mutual authentication to set up that secure link. And over that secure link, the other server is connected. So that's basically, that's the diameter thing. Then we have had a paper also last year in TNC in Poznan on using DNSSEC instead of the diameter solution. That has some advantages and disadvantages, of course. I'll come back to that later. But the idea is, of this solution is to store the certificates that are needed for the secure connection setup as part of the DNS tree under a specific domain. So for instance, for EduRoam, we would register a eduroam.org domain, which is secured by DNSSEC, and then have all participating organizations register below that edurome.org domain. So for instance, surfnet.nl would be registered at surfnet.nl.edurome.org in that DNS tree. And in DNS, the addresses of the authentication servers of surfnet.nl would be configured, as well as certificates for that server. So you can use self-signed certificates there because the trust really comes from the trust in DNS. Well, and that means that you also need to deploy DNSSEC. Another solution here is to use RADSEC, which is a proprietary extension of the Radius implementation. OSC does that, who's the owner of Radiator. So what they did actually is to replace the UDP-based Radius transport with a TLS-based Radius transport. And for that TLS connection, they used a mutual authentication based on certificates. So you have you need to maintain a certificate authority for the trust in edurome, often also trust within a country, and you need a DNS registry, say, of the authentication service. So if you look at those three solutions, you can compare them in a different set of various dimensions. So first is on the basis of trust. They differ in terms of trust, say, diameter, and RADSEC trust is obtained through CAs, Radius DNSSEC on DNS domains. Diameter, and then you have to of course, if you are in multiple roaming domains, you have to check, say, to which authentication server you have to come. You have to be sure, say, to pick the right roaming agreement to authenticate that particular user. So for diameter, you have to select the proper certificate of the user, so that's almost automatically. For DNS, you have to select the proper top-level domain to look up the institution where the user belongs to. And for RADSEC, you also have to select the certificate because the trust is really the same, diameter and RADSEC. Because what RADSEC actually did is take the goodies from diameter and ported that back into Radius. For the others, it's more or less the same. But there are some issues. Say, diameter is not really widely deployed right now. Mainly the translation agents between Radius and diameter, which are needed for the wireless authentication, are a little bit lacking. Certainly during the time we did this activity, they are being worked on, I think, in a European project right now in Daedalus, but I'm not 100% sure about the current state. And DNSSEC has the same problem. Has also been standardized. There are also products available, but it is not widely deployed yet, so it's not very easy to. There are not, say, the top-level domains are not signed to DNS, so it's difficult to set up the authentication structure with that. And RADSEC DNS Roam, okay, that takes the best of both worlds, but it is proprietary. So there are no real champions, I would say. So what we did late last year is to set up some test configurations to go ahead with RADSEC, because it has an implementation available. It is compliant. Say it offers an easy upgrade of the current infrastructure. We did not need to deploy DNSSEC because that would mean that we also had to touch upon the DNS infrastructure of the institutions, and that's kind of complicated. So we selected a number of deployment scenarios that are more or less the extremes of being dynamic and maintaining the old hierarchy that we already know from the current edurome. So the first one is fully hierarchical, like edurome now works. So we have the institutions down here. Am I still there? No? They are here, and then we have the NRANs on this level, and we have the top level hierarchy on the top, of course. And here we have fixed trust relationships, so we don't use any information from DNS or whatsoever, and we simply used, say, the different transport mechanisms. Actually, we tested the transport mechanisms that RADSEC provided us. So we replaced the UDP with the TLS connectivity here. And the complexity that we had to go through here was mainly to set up a good trust architecture, because most of the NRANs have their own want to deploy their own CA. So there's not a fixed root CA. At least that's not foreseen, because it will be quite unmanageable to do that. So we actually, on the NRAN level, we had to set up our connectivity on both hosts. But we come to that later. The second step was to go to a mesh. So we had a radius or a RADSEC connectivity on the bottom, so up to the NRAN level, and then used dynamic setup on the national level. So we got rid of the top level node that did the roaming between the countries. So this was kind of an in-between step. And we used the eduroam.org top level domain here to find the correct authentication server. So we didn't really, because it's always also an issue, of course, to find the authentication server for a particular country. So we use that. So for instance, if we were to connect here in Italy, in some of the institutes from a SurfNet domain, we would look up into DNS the .nl.eduroam.org authentication server, or the surfnet.nl.eduroam.org authentication server, and it would point to the national NRAN. And that again would standard proxy that down to the surfnet.nl institutional server. And finally, we tested the fully meshed scenario where we put all the authentication servers themselves into DNS and got rid of the eduroam.org TLD, because we don't really need that, right? Because there will be you can look up any authentication server of any institution out of DNS. So it's a purely peer-to-peer thing. So we set up these architectures in different labs. The names are there on the slide, and we tried it out first between a couple of sites and then expanded it into more sites. So we tested a number of things. So authentication related scenarios like user does not exist or wrong credentials, so that kind of stuff. Trust or PKA related. So you present a wrong certificate, revocation things, that kind of stuff. DNS related, so wrong lookups, getting wrong DNS entries not found. Configuration related, so installation of certificates from the in your authentication server, in your radius server. Connectivity related, so an authentication server can be offline or whatever. And we looked into some performance issues like the overhead of DNS, which can be more, say, than a pre-configured set of radius proxies. So then we went through those tests and evaluated them with the participants. And here are the results, say, of each of those architectures that I actually presented. So the hierarchical thing, where we only use RADSEC for the individual connections between the proxies and use the same architecture as the current eduroam. The main difference is that we have TCP TLS instead of UDP, and that was preferred by most of the participants because it gives you an easier measurement of whether the remote server is actually up and running, because the TCP connection is dropped or not, whereas Radius uses UDP and you don't know that. You have to rely on timeouts and that kind of stuff. So this was quite appreciated because it's a very local optimization. The issue was here, I already mentioned that with the certificates. A mesh top level. That was also then it depends, say, on what you see here. It works, but you have to open up your DNS, your authentication server to, in principle, to an unknown remote participant. But although you use a mutual authenticated TLS sessions, it's still an issue that you open it up, say, the authentication server. And there are a number of parties who really didn't like to open it up because of obvious reasons. But still, it's still positive. Say, a large part of the participants do want to go into that direction. Fully meshed. There we ran into some problems of PKI management. Has to do with different configurations and different things. But here we had another even larger issue, because here we actually open it up for the whole world. In the second scenario, you only open it up for a restricted set of authentication servers that you might know, because it's the set of NRANs that federated in eduroam. So you could actually configure that into your firewall, for instance. But here it is more difficult, because any institution, and there's no way, say, to get that overview and to configure that in a reliable way in your authentication server. Okay. So, to wrap up, what we did in this presentation is to present some different protocol architectures that you might use instead of the current radius hierarchy. And we did also some experiments with RADSEC that were quite positive, I would say. We had some problems, of course, in the beginning, because actually it was the first realistic trial of the RADSEC implementation anyhow. So there were some issues, there were a lot of issues, say, in the beginning, in the first test of the scenarios, but they were fixed quite rapidly by OSC. So we had some good cooperations with them as well. But in the end it worked, and it was also sufficiently stable to test most of the scenarios. The features taken from diameter, like using TLS over TCP, proved useful from a management perspective, because it's much easier, say, to get an overview of stale servers. And then the issue of dynamic peer discovery, there we run into policy issues, like do we really see any, do the benefits outweigh the risks, say, is the main question there. And that's not really a technical thing, I would say, but it's more like a policy thing. So that's about it. Thanks.
Thank you, Henk. Are there questions for Henk? Okay, you're first at the mic, so go ahead.
Thank you. Kelle Geras from NTUA. So it's a bit a surprise to me to hear that it's easier to detect that you have network failures with either with UDP or TCP, because both of protocols rely on timeouts. So I mean, you send a packet and if you get no response in a specific amount of time, then you have a network failure. So unless you have to transfer big packets, like big payloads, harder than the MTU, then UDP is more efficient, because it's more efficient in terms of bandwidth consuming, and you can detect whatever you like either in TCP or UDP. So, I mean, failures could not be the deciding factor for choosing a protocol. If
I agree.
A certificate is not larger than an MTU, then you can do all of your work with a UDP transfer, because it takes one packet to transmit them.
That's true, but the setting is the difference, of course, in the typical timeout settings of both protocols. Like Radius is using a larger timeout than typically the TCP connection setup would take. So there is the main reason for doing that. But you are right, of course. I mean, you can configure your protocol stack in both ways, in a specific way, in order to not to have that problem. But then it also depends, say, on the configuration of the server on the other end. And TCP is much more reliable in that sense, at least in the tested proof.
Yeah, but the same works also for TCP. I mean, the configuration timeout for TCP is host specific. It's not by default a specific value. So again, this doesn't hold. I mean,
yeah, true, but talk to the system administrators who joined the test, right? So what I'm presenting here is simply the result of the observations of those. Maybe some of them are in the room? Yes. Yeah? Okay. Maybe you can comment on that.
Oh, maybe, may I?
Yes, because that's another participant in the test, so go ahead.
Yeah, I was participating and testing, and in advance of test held by you, and I can agree with your conclusions. For me, RADSEC is not stable enough to be put in production environment, and I said it more than twice, and I am quite surprised to put me on some slide where it's written that CESNet was working, and on some place you are writing that it's stable enough, it's not stable enough, and to be honest, I'm very doubtful if RADSEC and its idea itself might work. Colleague there speaking about TCP versus UDP.
Yeah.
I think this needs we have to be very pardon?
Yeah, careful.
Very careful,
Yeah.
thank you. Trying to put this in EduRoam.
I agree with that. There was also some discussion, right, initiated by you, I think, on the EduRoam mailing list of TF Mobility. I saw that. And you are right, of course. There are some real issues. The RADSEC implementation. The RADSEC implementation, like it is right now, I mean, I agree completely with you. That's not production quality. But the question of whether the protocol would or the ideas behind the protocol would not work, say, that's a different thing. Right?
Yeah, but not only implementation, whole idea. Why put into UDP-based protocol TCP, and that TCP is only transport stream for UDP inside?
Yeah. Okay. Let's take this line.
Let's take this discussion offline.
Yeah.
It was clear also in Henk's presentation that not everybody agreed.
Right.
It was an average number, and I think we have one more response from Stefan over there.
Yeah.
Yeah, I just wanted to say something about the UDP versus TCP and why TCP is better. The point is, if you use radios and you have a hierarchy, and some of the later hops is not reachable, the hop just before this one will drop the UDP packet. It will not send an answer back. And so all the hosts before that in the hierarchy will not get an answer back because the whole story was just forgotten. And so you have a risk that all the servers that are waiting for a response mark their next partner dead. Now, if you use TCP, you can use point-to-point verification. You see, if TCP was used, the next server, you know it is running because the TCP handshake worked. And if you then don't get a response, you don't get the risk of marking the server dead. You know it works. The request just didn't work out. That's one of the points that are better with TCP.
You're right. Yeah.
I'll leave one person to explain why it is wrong, and then I'm going to go to the next speaker.
Okay.
Okay, we'll discuss this further offline. Thank you again, Henk. Our next speaker is coming up from down under, literally now. Chris Myers of GrangeNet in Australia. And Chris is there, the Advanced Communication Services Coordinator, and does a lot of things there that you can all read in his profile on the website of the conference. But I think the best way of introducing Chris is the never-resting promoter of EduRoam in the Asian Pacific area. It is largely thanks to Chris and a number of other people like James Sankar that in Asia EduRoam is taking off so fast. So I think it's going to be interesting to hear Chris' ideas about it. Chris.
Thank you, Klaus. Chris Myers from GrangeNet. Talk today will be on EduRoam update in the Asia Pacific area. Wireless roaming for higher education and research, because we're focusing on the higher education area. And this slide pack was put together by, not just by myself, by other colleagues in the APAN area. Kevin Tang, Xin Kang Hu, and Wei Ting, but all from different areas of the Republic of China, from Taiwan, Hong Kong, and China itself. The first part of our talk will be on the Global Working Group. The Global Working Group was set up. It's basically a shared email list, and we met together at the first Eurocamp that was run in Torino, just up the road in Italy, and we all had a beer, all us people that wanted to do Eduroam, and decided that the group sitting around having a beer had some good ideas about developing Eduroam services further. And so we formed a boys club or working group for and called it the Global Working Group. We had a second meeting after the I2 meeting in 2005, and that's the second picture down there. And you can see the group had grown. We've been more colleagues from Europe, Australia, and Japan, and also from America. There's several faces in there from America as well. And we have conference calls when regular to discuss issues when issues come up internationally so that we can help each other out. What we're doing, we're looking for standards and systems for safe roaming internationally, because roaming in your own institution or roaming locally between friends is different to roaming anywhere with everyone and anyone. So our main aspect on is trying to make the roaming safe internationally, across borders, into different areas, different places with different rules and different ways of doing business. We also are working on the Eduroam NG program and coordinating that internationally, so that the Americans are working with the Europeans and the Asians and Australians and Oceania Pac are all working together collaborative, so we don't come up with three systems that don't work together, because that would be rather unfortunate. And the peering policies, which is kind of a routing term, but where the top level servers meet, and also on frameworks. There are representatives from Europe, the USA and the Asia Pac region. There's two obvious places missing there, South America and Africa. And if anyone from those areas are interested in Eduroam, please let us know. We're more than willing and really hoping to enter into those markets soon. Our current Eduroam environment is a hierarchy of radius proxies using shared keys, and everything's manually configured, whether it be default or by realm, by realm, by realm, by realm, by realm. So it works. There's not a great deal of problem with it, depending on, that's a debatable question with a lot of people, but there's a lot more we can do. So this is where we've been looking at the future, which we heard about just before with RADSEC. So radius discovery, or RADSEC, is an interesting way forward, and globally we're interested in this idea, whether it be at national levels or at institutional levels. That's still a big debating point between all the groups. PKI secured links that gets rid of our shared key secret problem, and that will greatly enhance the security between radius servers. So we're very much hoping to move forward into that via radiator diameter or a free radius version that supports these parts. And we're also very interested in possible SHIB attribute passing, so a EAP SAML type technology where we can integrate the security and attribute release policies within Shibboleth and into the way we are quite comfortably passing information backwards and forwards globally in this global federation. We've also set up a list to coordinate our efforts at the top level to make sure that we get our realms right, so you can actually route internationally and globally, because it's not much point when Lithuania might join in Europe, and if the rest of us don't know, we won't route that way, because at the moment at the top level we're routing by realm. So it's very important to have this list. It's got all of the people that actually manage the top level radius servers on there, so we can actually coordinate our efforts and make sure we get it right. And here's a picture of the existing hierarchical mesh at the top, where we've got the two European servers, the two US servers, and the one sad and lonely Asia Pacific server. We are looking to put another one. We're just looking for a home. This section is on the update for the Asia Pacific region. Some of these logos may look a little different, and I know there's been a lot of logo debate, but we had some very clear problems in Oceania and Asia Pac, where a lot of the students just could not or did not understand what Eduroam was or read the logo. And after specific requests from certain areas, the top two logos you see are actually in Chinese, and the bottom two logos in two different dialects within Japanese. And we mandated also that these logos get used with the traditional Edge Roam logo at the same time, so we all know what's going on. What is Edge Roam's core requirements? Edge Roam allows roving researchers to log in with their usual username and password to wireless networks that participate in campuses around the world and transparently get access to resources either locally at home, depending on the security policy of the local place, like visited site. Really, in Asia-Pac, this is our mission statement within Edge Roam. And the words highlighted are what's important to us. We're allowing people to do this, to log in to our networks, and it has to be transparent. We don't want a CEO trying to work out how to reconfigure his wireless adapter to talk to a different type of SID or a different type of encryption or a different type of protocol or application or gateway. It's just not going to work in our realm, and I would never expect all of my users to be able to do that and be technically savvy enough to know that I'm going to this country, so I need a different application, or I'm going to this country and they're doing web redirect, I'm going to this country and they're doing something different. It just pollutes the market in our realm and will ultimately end up with the project not going forward successfully and us integrating it into actually getting users to roam and use it. All the successful programs like iPass, AT&T Global, etc., easy client or simple way of accessing it, or it's always the same. So the experience and the expectation of the user is the same wherever they go, everywhere. Unless that's the same within Asia-Pac and within Europe and the US and Africa and South America later on, we will not be able to roam. Our users will be able to roam, but they won't know how to roam. So this will be a serious issue for the project. At the moment in Asia-Pac we have Australia, Taiwan and Hong Kong federated, and we've had substantial interest from China, Japan, Korea, New Zealand when their NRAN comes up, and also Australian universities that are in the Asia-Pac area. A lot of our universities in Australia actually have a lot of offshore campuses within different countries within Asia. Next shows the top level service within Asia Pacific. The red lines are connected virtual links between countries, and the dotted lines are the proposed links that are coming up with interested sites. First servers are online in Australia. The second server, we're looking for a home in another country within Asia-Pac, and we're hoping to do that shortly. And the top level server in Asia-Pacific, of course, is connected to Europe and the US. And one interesting point at the bottom is we're mandating within Asia-Pac that 802.1x is used. I know that's different in Europe at this time, but within this area we regard the security concerns very highly, and we don't want to see anyone's credentials roaming between countries actually being compromised, because that will be an ultimate killer for the project. Now we're going to move into some individual updates that I've received. The first one is from Taiwan. This is from the National Science and Technology Program for Telecommunications. It's coming out of the NCHC, which is the National Centre for High Performance Computing. You can see they've set up a team. They actually already had a fully functioning wireless roaming system independently developed from Edge Roam. They'd never heard of it before, but they already had it working. They've got a very formal advisory board, executive department, co-executive department. As you can see, it's been a well thought out and well-driven program. And when you see the number of, this is the model of what they're developed, which is they're using web portals, so web gateways, web-based redirect gateways, and VPNs to pass backwards and forwards between multi-realm radius servers. And I know that sounds like a contradiction to what I said before, but we'll find out. The roaming centre national point at the top is what's federated to Edge Roam. And when you have 64 universities connected and over 550,000 user accounts, you have to have a formal process and a formal way of delivering these services. And these are the unis that are currently connected and roaming in that area. Most of them in the considered for APAN aren't actually currently ready to join Eduroam within Taiwan. Most are using web portal style, and that's they had some problems originally because they've been doing this for quite a long time. So the Attitude-1X environment was costly, and not all the APs did it at the time. So 2% of the universities in Taiwan are already doing Attitude.1x, 98% are doing web portal, but 80% of those universities are highly interested in connecting to Eduroam. So NCHC brought in a Attitude-1 mechanism, promotion and training. So they're actually going out, promoting Attitude-1x and training the individual users and the individual institutions on how actually to deploy Attitude.1x, helping the universities, and also building cookbooks. So as the unis become Attitude-1x enabled, then they're allowing them to roam outside of of Taiwan. They can still roam within Taiwan, but as we move forward, then they get access to Eduroam. Next update is from Hong Kong, who joined, I think, last Thursday or Wednesday, so it wasn't long ago. The first part is a bit about the university. Basically, we've started with one university in Hong Kong, which is Hong Kong Polytechnic University. It's traditionally known as PolyU. It's been around for 70 years, has a large number of students. I'm not going to read through the slides. Graduates, very proud of what they're doing. They've got approximately 14,000 students in different areas. And here's some information about the university. But within the wireless context of what we're discussing today, they use wireless LANs with WEP since 2001, so they're a very early adopter of wireless within the region. They obsoleted WEP and moved to WP802.1x since January 2006, so they'd already started to move. And, oh, by the way, there's 8 other institutions in Hong Kong, so this is the main institution that we're first testing with. At the moment, they have 300 APs. By the end of the year, they expect to grow that to 900 APs covering the entire university. They first joined Eduroam in May 2006, and they're willing to operate the top-level server for Hong Kong, so they'll distribute out to the rest of the Hong Kong network, which is HARNET, H-A-R-N-E-T. And HARNET was established in 1985 and 1991. And it provides the research services, so it's the NRAN for Hong Kong. And now I'd like to let you know that we're currently working very closely with a university in China. China's been is an interesting place for us to look at for Eduroam because it has over 1,000 universities and a user population which is incredible. Like it's absolutely huge. So when we enter that area, it's going to stress test everything we're doing with Eduroam. The University of Electronics, Science and Technology of China has agreed to trial the service to begin with, so we're going through the moves at the moment of how they can connect, how they can deploy it, how it fits in with their political, within their legal requirements within China, and we're moving through quite quickly with that with them through Professor Wei Nong Hung. And page up. One interesting fact there, which I was astounded at, is the university campus is 58 hectares, that's incredible, with 55,000 square metres of area and 1 million volumes in their library. So the resources there is incredible. This is a diagram of their current infrastructure and their wireless infrastructure, which they're now going to put a separate VLAN on, connect into a radius server and then into a top-level radius server for China and push back into Eduroam. And they're rapidly progressing on this. And it'll be a case for the rest of the CESnet to then connect to Eduroam to see how it functions within their environment. This is an update from Australia. We've been playing with this for a little while now. So we have 29 sites deployed, 31 sites in development, because a lot of the Australian universities are distributed either by states or within one state. Over 19 institutions connected and one food court. One of the unis decided, the shopping centre across the road from them came and said, we want you to put wireless APs in our food court because all your students come here, use their laptops, so we want to keep encouraging that. So they actually went, well, we've got EduRoam, so we'll put it in there. So they actually deployed EduRoam. This is in the centre of the city. So this very, very large food court now has EduRoam coverage in it. So you can sit there, have McDonald's or whatever junk food you like, or healthy food, because there is actually healthy food there, and join EduRoam. We have over 12 more universities lined up and in the way of being connected. Also, we're connecting one of the national libraries, and the CSIRO, which is our large Commonwealth organisation with 57 sites around Australia, are also in the process of connecting. And we've also been looking at the option of connecting home offices for staff and staff. We have an EduRoam portal which we use to distribute our information and also share off to international links. We keep our policies, procedures, services. There's also a large extent of mailing lists, including abuse mailing lists that people can send if students are behaving badly. Security, we have minimum standards of 802.1x, WPA TKIP on the APs for wireless security, and an EAT method recommending EAT TTLS. We did this because we believe the weakest point in our EduRoam deployment was going to be the site with the lowest amount of security. So the reasons we didn't do WEP were quite simple. So WEP's basically hacked, so we didn't want to even go down that pathway. You stand here, you might as well be telling everyone in the room your username and password, so that's why we didn't go down that path. The second part of it is, the second part we were looking at was web redirect, and with web redirect, you might as well be sitting in the audience and telling the person next to you what your username and password is, because it's just unsecure within our environment. And VPNs didn't scale to what our requirements were. To help out with the users, we brought in education. The two people you see in your right-hand side, they're both Americans. They're experts on 802.1x, including Chris Hessing and Michael Getz. They wrote the book on 802.1x. Literally, if you go to the book and buy the book on 802.1x, it was Matthew Getz. So we invited them to Australia and ran workshops around the country to teach the universities how to deploy and manage 802.1x environments and to configure radius for it. And we also offer support, debugging and site visits, so we actually go off-site to the universities and help them configure and install EduRoam on their sites. At the moment, what we're doing is letting the clients know. So this is our PR piece. So what we're actually doing is putting this out to all of our users, so the actual people who we want to actually roam who don't know about it because only the IT departments know about it, will find out how they can do it and where they can find out more information on how to deploy EduRoam. We also completed our policy and it was ratified by Cordit, which is our body of all the directors of IT of Australia, and they actually agreed on a policy and ratified it for us, so we didn't then have to run around to every single university and say, do you agree with how EduRoam should work and how the policy fits? And that was thanks to James Sankar from ARNet. Last part of EduRoam, it's a global service now. As you can see from the picture, it's Turin, Taipei, Australia, US, Turin, and Melbourne. So we're actually seeing people using it and being enthusiastic globally. So we need to think globally and be responsible globally within the service. So now it's everyone else's chance to join and collaborate. Here's some links and also some information on EduRoam in Australia. There's one thing we do at the end of all these talks. Some of you may have seen this before. If you're part of EduRoam, want to be part of EduRoam, used EduRoam, or would like to join EduRoam, could you please raise your hands in the audience? I'll just step back because there's a lot of people here. And these do get put on the website. One more, over this way. So, we now have evidence of everyone who should be or are joined. Excellent. It will be used against you in a future court of law. Thank you. Any questions? Oh, microphone coming. Excellent. Please repeat the question.
How much of interinstitutional roaming do you observe now on within, say, Australia or even wider in the Asia?
Okay, it's low and it's too low. And the reason for that is we're working towards reaching critical mass for the institutions connected. And basically what was happening is the institutions were connecting, they were going, cool, it's done. And that was it. They weren't letting their users know, or the communities know about how it should work. So the next stage of the program we're going through now is a publicity campaign where we'll be giving talks to the universities, as in the academics, researchers, students. We're hoping these pamphlets will get put in their O-Week bag so that every student then enrolls, finds out about how Eduroam works, or information from the uni on how to do it, encouraging that. Signs up where the APs are, posters up in the unis we're hoping to do next. So this is, we're going through the phase now where we're going to increase roaming by publicising the service to everyone. At the moment it's the techies and it's a few of the IT directors. Like one interesting outcome from it, which was something we didn't expect, in Victoria, which is part of Melbourne, all the IT directors in that state have mandated Eduroam must be running where we hold our meetings, because they want to prove to each other they can do it, and that their CE, they can put their Palm Pilot down or their Windows CE device down, it connects, their laptop connects, they can get their mail and go, look, it's working, look how good we are. But that was something we didn't expect. And we also end up with all these micro communities bringing themselves together. Like we thought we'd build one big community in Australia, and what we ended up happening was little fragments of communities getting together to help support each other to develop the service as well within each state. Which, when we found out that was occurring naturally, then we encouraged it as well and then used those groups to coordinate nationally into each other. So it's low, but we're expecting it to grow over the next 6 months, substantially. Any more questions?
Then thank you again, Chris. The reason that you saw me walking out in the middle of the presentation was that we lost the video conferencing, but everything seems to be up again now. Can you see, Philip? Yes. Okay, I can't see what you are seeing, so that's why I asked. Philip, can you hear me?
Yes, I can hear. Can you hear me?
Yes, perfect. Okay, the next speaker is going to be Philippe Hanset. Was that okay, Philippe? He is he's a Belgian, but we export our Europeans all over the world, and he is at the University of Tennessee, specifically, but in general in the US, making sure that also the Americans see the light of Eduroam, and he is going to share with us what he can tell you about Eduroam in the US. Philippe, the floor is yours.
Thank you, class. Thank you, everyone, for being there. So on slide number 1, I will each time mention which slide I'm on. Slide number 2. I'd like, of course, to give credits because class is saying that I'm promoting Eduroam in the US, but there are many people working on Eduroam in the US. Kevin Miller from Duke University, Chris, who is co-chairing the group with me, Chris Misra, who is co-chairing the Salsa group. Those two names, Andy Rosentreich and John Volbrecht, will be familiar to you. They worked with Merit Network, and John Volbrecht was actually involved in the early stage of Radius Proxy. Merit Network is one of the initiators of Radius Proxy. So Jessica Beebe, Steve Olczynski, and all the nice people that share those conference calls every other week. So I'll give you a brief overview of the edu-roaming that led to our experimentation. As I was mentioning, Radius Proxy was used extensively for modem pools, and Merit Network did a lot of coding for the roaming between modem pools. I don't know if you remember the years of CompuServe that was giving you the same identity no matter where you went in the US, but that was a famous Radius Proxy implementation. So of course, in our case, IEEE 2.1x was ratified in 2001, which is mostly what we are using for the proxying. 2.1x mentions that you can use anything, but I wonder if anyone is using anything else than Radius at the moment. Diameter, of course, may come. Also, to be mentioned, Radius Proxy was used earlier by University of Utah. Chris Myers mentioned Chris Hessing. Well, Chris Hessing and a few other folks were using the Radius Proxy to solve the problem of disconnected IT departments. So it was a way for them to interconnect different departments but have a central authentication method. And they were already using Radius Proxy at University of Utah before I think edu-roam was implemented. And class, please correct me if it's incorrect, but I think the Tirina created the TF mobility early in 2003, and the first edu-roam enabled access point was in Zagreb, Croatia, in May 2003. So then Internet 2 took a look at what was going on and decided to create a group to follow up on this activity. That was in December 2004. We are a little slow sometimes. So this year, in April 2006, we finally had 2 servers and our first experiment where Chris Myers authenticated to Australia and Aaron Verhagen authenticated at SurfNet while they were in Arlington, Virginia at the member meeting of Internet 2. Slide number 4. So what is really FWNA? It stands for Federated Wireless Network Authentication. It's a working group at Internet 2 that is evaluating. We only use either 2.1x. We don't do VPN or web redirect. So we're only evaluating how either 2.1x can be used to roam between institutions. Local, I believe very much in local initiatives. I would like to implement that at the state of Tennessee so people can move between different universities and maybe high schools, etc., using edu-roam. Also to look at implications of roaming. You will find that strange, but I was in Switzerland in February, and for the first time I saw a sign that says legal drinking age is 16. And as you may know, in the US, the legal age is 21. So I always thought, oh, that's interesting. I bet when parents, American parents visiting Switzerland see that sign, they may be scared, you know, if they have very strict policies on what their kids can do. Will this federated world prevent us from drinking? If I'm an American visiting Switzerland, will I be prevented from drinking at age 16? I hope not. So it's also an experiment, of course, that uses root radius servers that we try to connect to as many US universities, institutions, and schools. And it's connected to Europe and Asian Pacific. And really, FWNA is another name for eduroam.us. You will see in my presentation I go back and forth between FWNA and eduroam.us. Slide number 5. Why did we really get interested in FWNA or eduroam.us? Well, I speak for myself. We had a large wireless network. In 2001 it was finished. We had 1,300 access points, and it was very open. People could join that network with not much to do to join it. And then came 9/11 and the Homeland Security, and we got asked to secure all the networks and make sure that the institutions knew who was at what time on the network. And now it's starting to be relaxed again, a little bit. And we are open, we are asked, because we realize that we need to do business after all, to reopen those networks and for visitors, while maintaining still an adequate security. But somehow those guest accounts that we have created with web interfaces are not good enough. I was meeting with the conference people not so long ago, and they told me that they would like to make a difference between regular guests that can only do maybe email, web, and a VPN, and special guests. Well, how do you do that? Does that mean I have to start to become a user account manager, and every time there is a conference create special accounts? And so EduRoam may fix some of these issues, definitely, or federations in general. So where are we today with FWNA? As far as the architecture is concerned, we are following the European model, what I call eduroam.eu. We have a hierarchy, we have 2 servers connected to Australia, the Asian Pacific, sorry, connected to Europe, and we only use 802.1x. We have an experimental service in place. I mentioned that people connected the member meeting. We have 3 or 4 universities connected to the test. And we are also actively developing tools to make this experiment more convenient. For instance, one of the tools we've developed is a web-based interface. So people willing to join can conveniently exchange shared secrets over an SSL tunnel to a web interface with the administrator of the top level. Also, we can get the IP information, etc., without having to exchange emails. I say, like, wait for 7 emails and my password will be there. We are also developing some tools to block connections, to see if really someone is visiting us, let's say at University of Tennessee from University of Michigan, and they misbehave. How can we block them? We have a nice little web interface that we implement on the top level that will let you disconnect for a certain amount of time an 802.1x session. It has problems because you cannot disconnect an 802.1x session. You can disconnect the next re-authentication. You cannot disconnect the existing authentication. And as a matter of fact, during your testing, I was on in my office the whole afternoon on one access point, though I was disconnected and being authenticated across the eduroam architecture. Actually, it was with a test account at SurfNet. But I was authenticated at SurfNet for the whole afternoon, even though I was being blocked on the top level. It's only until I moved to another access point that my session died. So this is my best attempt. I'm using some tools to show you slide number 7, sorry. To see where we are with in the US. So you can see that there is a major difference, is that we are not structured with NRENs. At least in Tennessee we're not, and not many states have NRENs where you connect to, and then the NREN is connected to a national entity. You can see that on the left-hand side, we have Penn State University is dually connected to root servers. Merit Networks dually connected to our root servers. And University of Tennessee, we have 2 Radius servers for redundancy. So we end up being quadruply connected. Overwhelming. if many universities start to do that, of course. If you look at the European model on the right-hand side, I mean, I'm sorry, it's just representative, okay? I just use Germany, France, England, and Portugal for examples. There are many more connected to them. You can see that the NREN architecture really helps. You have basically a political structure on top of the existing hierarchical structure that matches the EduRoam hierarchical structure. Same in the Asian Pacific region. You end up with local servers connected to a root server. We'll see where that goes. It might be interesting. Slide number 8. What do we see as challenges for FWNA? Or really some of the challenges of 802.1x. Because it's a layer 2 technology, we have noticed that we don't have many ways to communicate with users. Yes, you could authenticate them on the infrastructure, then only hand them a temporary IP address, still make them go on a web portal, make them sign some policies, and then only give them an appropriate IP address. But that defeats a little bit the purpose of EduRoam. EduRoam is redesigned so that you hop on, you're connected, and you can do your work. Especially if you think about devices that are not convenient with web browsers. I'm thinking IP phones, small devices. What's another challenge is that it's decentralized in nature, and it's very complex to troubleshoot. I don't know if you have ever troubleshot this, but you have to look at so many levels of radio servers that could fail in the way. The mesh solution may solve some of this, but we also have to provide each other a lot of access to other infrastructure radios. Will people be willing to do that? That's definitely one of the challenges. I hope it will work. Another big issue is when you roam between access points, you each time do a long distance re-authentication. 802.11i does a pre-caching, so if you return to that access point, you will not have to do that, but every time you go to a new access point, you will have to do that. That's not very nice, isn't it? You're going to, if you're Portuguese and you're visiting the US, every time you roam to an access point, you're going to Portugal to be authenticated. Policies are limited, definitely. EAP attributes, how many access points really respect that and let you use them, how much coding are we going to do to be able to enforce some policies. Also, of course, that's always the discussion. How many policies can you enforce today with the state of the art of filtering is really VLANs and IP filters. It's not that we have many things we can do anymore. So you will end up with a lot of policies to choose from, but not so many tools to block people from. So interesting challenge as well. And definitely a large challenge is that in the US, the adoption rate of 802.1x is very low. Mostly, I think, because the clients have not been released. The EAP methods have not been standardized. EAPP, PEPT, TLS. If you start configuring, for instance, in a university, we have to change passwords every 6 months. Well, try to explain to users how to go and dig deep in the secure W2 client, how to go change those passwords. The first thing they do when they join is to enable automatic login. So when they have to change that password, they've completely forgotten 6 months after how to do that. What are the next steps we see with FWNA testing in the US? Or at least it's probably personal. The group has we all have different views on this, but I'll expose to you some of what we talk about. In my case, I would like to explore what Henk was talking about. Definitely see how RADSEC, diameter, and DNS
can solve the issues of security there with all the issues that you have been talking about. We definitely would like to improve the 802.1x control, because it doesn't matter what you do with 802.1x. Even outside of the realm of headroom, you cannot control 802.1x. A class was saying, 802.1x is just a key to enter a room, and then once you're in the room, you're in. Well, sometimes I would like to kick users out of the room, close the door, and not let them enter back. I'm a network operator. I like to control this. 802.1x does not give good controls over that. And that's beyond wireless, it's also for switches, etc. We will definitely need to work on policies. There's a lot of talk about Trusted Network Connect, the Cisco NAC, and the Microsoft NAP. How can we mix this with federated networks to control access? Because federations have talked a lot about privilege on applications. How can we mix that with all the issues of network access? Do we have to be very fancy about that, or really network access is join or don't join, or will we have to enable 1700 VLANs to differentiate all these different policies that we want to do? That may be an interesting issue. Also, user privilege. I was mentioning to you the case of Switzerland, the legal drinking age. For me, really, I like the idiom, when in Rome, do as the Romans. You join my network, if you are a high school kid, do I have to worry about you surfing porn on my university because we don't have the same filters as other people do? That, I don't know, honestly, I'd like to see how to enforce that. I will stick to when in Rome, do as the Romans, to simplify my life, probably. Slide number 10. What are other uses of FWNA? I've been working with a group of sensor network involved people, and one of the issues is definitely connectivity. You have a lot of wireless networks being developed all over, and people that have sensor networks would like to join them, because one of their issue is to have affordable infrastructure. You cannot assume that you will join a GSM network. Those are expensive, and those sensors can eventually send a lot of data. You talk about environmental sensors, there's oxygen, this, and all kinds of parameters. And I'm not even mentioning the seismic probes. They send data constantly. So having maybe a Wi-Fi network that's available locally that they can join may be quite fantastic. And FWNA, EduRoam, could be quite a tool in that respect. Sensor may end up being more mobile than humans. Researchers. I remember when I used to be a scientist in a previous life, and I was doing a lot of measurements in France and Luxembourg, and I wish at the time I could have joined a network, or in this case, it will not be me, it will be my sensors. Let's say I'm a specialist of water quality from Belgium and I want to do science in France. Well, I need to connect maybe 500 sensors on the same watershed. How will I do that? I think EduRoam will be a great tool for that. But in that case, you're not connecting an EDU person. You're connecting an EDU gear. You don't want Philip handset to authenticate those sensors, because I may leave my institution and those sensors may stay there for 10 years. So how can we do this? I'm sure there are discussions and on the TF mobility. Stefan was mentioning EduGain. I've not read enough on that. I will definitely document myself on EduGain. I may start some discussion on EduGain to see how that can solve some of these sensor networks authentication. Also, what kind of EAP will we promote for people that deploy sensor nets? They are coding sensor networks right now. They are using IP in many cases. though they have power limitations. So we have to be very frugal in the way we do those EAPs. We cannot start exchanging packets constantly because they're very little power when they're on the field like that. They're, solar panels, not much. Especially if you put solar panels in Belgium or in the Netherlands, you may have no power. Also, how can we provide, using EduRoam, additional facts? In the community I met, I call it the AAA as an analogy to radius. But in our case, it's really about availability of the networks. Where can I find Wi-Fi networks? I need maps. I need a lot of information systems to know where I can join. What is the ability of the network I'm joining? Can I join 24/7? Are there bandwidth limitations? Is it shut down during the summer? Who knows? Or in the case of a solar panel, is it shut down during the winter? And also, what kind of authentication am I expected there? If everyone is using a centralized thing like EduRoam, maybe we don't have to worry about it, but do I have to make sure that I have a little gateway, a web gateway that can do web authentication to that specific university? That's definitely other uses of eduroam.us or FWA that I see coming. If you want to join FWA, you're American, you have Americans in the audience and you're not aware of this, here is the information. I will not stay too long on that slide, just go look at the presentation. You have plenty of information there. FWNA, the very bottom link is fwna.ns.utt.edu. You will see that's how you can register your radius with us. It's not automatic, it will be too easy. You will receive a key and then we will authenticate you after human intervention. Also, some of the FWNA information you may check if you want to know what we are doing. You can join this website. Bi-weekly conference call. Actually, yesterday I checked the Webster and it seems that semi-monthly or bi-weekly are really the same thing, or every other week. And so you can join our discussion list if you want. It's salsa-f-w@internet2.edu. Just in case there are spammers scrolling. Well, thank you very much. And the floor is yours, class. Sorry.
Thank you, Philippe. I took a little liberty with your last slide. I hope you don't mind. Are there any questions for Philippe? Over there in the back.
Yes, in regards to mobility, I'm actually new to this project at EduRoam. I'm from Central America, so I'm looking forward to joining the community. When I first heard about the system, I thought it was solving the problem of roaming within a local area network, something that you touch upon with the .11i standard and also the .11k standard has something to do with that. My question is if you think that EduRoam will at some point focus its aim or work in solving that issue at the local area network level for roaming, or if you think that will have to be a separate project that will take care of that.
Yeah, that's a very good question. I think that you have two approaches. Right now, EduRoam is taking the approach of top-down. You have a large hierarchical architecture trying to promote that to people, that EduRoam could be a solution to their problem. I believe in bottom-up, actually. You could have communities like Tennessee doing an EduRoam-like architecture, but if you look at the architecture, it doesn't prevent from still being connected to the uplink EduRoam and have your local servers. It's really up to you to organize yourself within your state, within your region, to have a local server for the region, promote maybe independently. You don't have to connect to Edroam up front if you don't want, if you are scared by the policies. And then once you feel ready and comfortable with your community, Edroam, let's call it, then join a national infrastructure. I think it's completely compatible, and it doesn't have to be disconnected, or it actually can be disconnected. All options are open, I think.
Other questions for Philippe? I guess it was completely clear, or people want to now be the first at the coffee table, because we are quite early. But I want to thank you again, Philippe, for coming to us all the way from the States. Hopefully next time live again.
Yes, yes. I think every time it's in a northern European country, the university doesn't mind funding my trip. When it's too warm and too nice, they feel I'm going on vacation, I think.
Okay, also thank you all for attending this session, for your questions. I specifically want to thank also the video people for making this possible. They have been working very hard to bring Philippe in, so thanks for that. I do want to remind you that we really want you to fill in the review forms, so please do so, preferably online, in order not to have someone at Terena typing for days in a row. And see you back here after the break, hopefully. Thank you.
Enjoy coffee. Bye.
Bye, Philippe. Nothing.
Nothing.
But others have.
To be honest, this one is awesome. I've never seen.
Oh, sure. Which is
9,000, which one? 9,000. So you can take it on the road, the new keyboard. Wow, what a performance. Probably due to the video stream. Yeah, well, it's just, yeah.
slide it over to the side, but
Really?
to send it to
Yeah. What I had before the E10 in M600. Before that is also with the Windows Mobile 5. It's new, it's like a PDA, where you don't have no keyboard, you just have a pen. And that really started pissing me off, because every once in a while, I mean, I use that when I go working, but not when I go coding. I go coding or anything, do sports or anything else. I have a Nokia.
that's why I have my other phone
Yeah.
now, because I don't want to carry the big phone.
For me, is when I am out on my free time, I don't need my agenda. But when I'm working, I would like to have my agenda with me. And this one, for me, is the perfect, deal in size, audio
and it even has wireless. It talks 802.1x.
Prova? Prova? Prova?
You better sense them. Well, why would he have asked otherwise for a Mac?
Genau, im Moment bin ich hier am Rechner rebooten. Ach, also hier ist ein Loch im Boden und dann fällt das Stuhlbein da rein. Das ist irgendwie, das muss man sich mal reintun. Hier, wupp, das ist gestern auch schon mal passiert. Wupp, dann rutscht man hier weg. Super, ne? Nee, irgendwie, ich bin im Moment hier gerade am Rechner rebooten, weil da irgendwie die Hälfte nicht funktionierte. Ich glaube, das ist so. Also das, was jedenfalls da im Links ist, müssen wir mal gucken. Irgendwie, also die bringen uns ja hier zur Verzweiflung mit diesen Logins irgendwie. Weil geht's jetzt wieder nicht? Hier ging es nicht. Und jetzt versuche ich das mit dem USB-Stick, aber der hat irgendwie, Windows hat USB verloren. Nein, das Problem ist, Sie erlauben immer nur ein simultanes Login. Das heißt, wenn man sich nicht richtig ausgeloggt hat. Ja, oder wenn das System das irgendwie nicht richtig mitgekriegt hat, dass man sich ausgeloggt hat, das funktioniert nicht so hundertprozentig. Und wir müssen jetzt immer hier hin und her zwischen den beiden. Und das ist irgendwie. Das ist irgendwie. Hallo. I have. Yeah, you can check. I have a presentation on here. This is this one, huh?
Yeah.
Is that right?
No.
This is what I downloaded. Hi. So yeah, let's try again to get an internet connection
I
here.
can bring a USB key.
Yeah, but I try to get. Maybe it works now.
Okay. Yes, you have to log out from.
Yeah, now it's at least it's definitely not working there. And now we see whether it works. No, it just doesn't work. But it's via cable. Yeah. Do you have the USB? Yeah. Okay.
Have you got all the slides already uploaded?
Well, I'm trying, but there's this machine doesn't get a network connection. Here we are. This works. And now. So that was it.
Just plug it in here?
Yeah. You can just. Yeah. Here you go. It just looked, yeah. And you just bring it over. SE is Slovenia or Slovakia?
Slovenia.
Slovenia, okay. That's it, yeah, it works. Now you're experienced. And are you using the Mac stuff now, or because you brought a Mac, or?
No, this is for the last presentation.
Yeah, sure, but for the video conferencing, are you now using this Mac tool, or?
Yes.
Yeah, because it was the only way to.
Was the only way to get a decent quality. I mean, because on the other side they don't have any hardware H323 and the software client like let me disaster.
It's okay. So I'll be presenting here, or how will it work?
Yeah. You should. Well, the point is.
I see you fell into that trap again.
Yeah. It's really. So the point is, we need the video conferencing there. So the best will be we have a PC here, and you can turn it or so, yeah, as you like it. And you have to. Well, you get a mic. I hope. Yeah. No, where is it? Where's the mic?
Any of these.
That's a mobile mic.
Oh, there's also the mobile mic, yes, somewhere.
Maybe a.
Klaas took it with him.
Klaas took it?
Klaas stole it.
Klaas stole it? Who's the guy?
Sitting there. Sitting there.
Ah, the mic? The mobile mic. So, what you shouldn't do is go in front, because first of all you get a feedback with the speaker. Yeah, you can turn it on and.
This is off again.
And also you're out of the lights. They won't see you from the camera. Okay? Otherwise, it's pretty much straightforward.
Yes, Arnes. This microphone.
Can you hear me? Okay.
Did you get the custom slides from the server?
Yeah, I have.
Okay, so they are the last
The slides are there. Just arrived. So.
Accelerator is this?
It's just an old model of eyesight, and this is a new model, the secret one. One you can hide into a watch.
But it's turned towards the. Yeah. Okay. It's intentional.
It's intentional, yes. The speaker wants to see the audience, and that's the only way to let him see the audience. As an additional external camera. Otherwise, you only see me.
It's nice.
It's one of the best webcams which exists because it's autofocus, auto anything, self-light. And now the Ministry made it as little as this one.
Okay.
It's the same.
Same
It's the same camera.
Totally the same.
Yeah. It's incredible. complicated. Even more complicated. I need to use I check.
That's not there is a small,
stuff.
but
No, I
you
won't
don't
see
have
it.
a watch, or
No.
I can put it down here, but and I'll
No, I'll
point.
just take the phone. I think I'll just take the phone.
Yeah.
Oh, you mean near the laptop? Yeah, that would be
Yeah. Also, I give you a sign for the last 5 minutes. But you shouldn't if you take the watch. Oh yeah, I still have this.
No, it's
Jesus, yeah. It is a little bit ahead, 3 minutes on purpose.
You know what they say. Time flies when you're having fun.
It's empty today. Quite empty. Everybody's going swimming or is tired. Making
It's
it's still coffee break. Yeah. Everybody's still preparing for the gala dinner. Huh? Preparing the.
Getting dressed for the gala dinner?
already prepared.
Sorry.
Getting dressed for the
Yeah,
gala
yeah.
dinner? Preparing themselves.
Yeah. Correcting the outfit. And will he be seen on on one of the screens or?
That's what I will try, yes.
Yeah.
But I'm not so sure. Okay. Wait.
And your name is pronounced Rock-Papish. Are you okay? Can we start or?
Yes, well, I'm never sure it is okay. It's
Well,
not
yes,
yet
but
okay.
as okay as it can be.
I
Huh?
can do silent. Yes, you can start.
Okay.
Why don't you sit in the middle?
Yeah, it's hard to see. Huh? The middle is empty.
You need to ask people sit in the middle, people, please. You should ask people sit in the middle
Yeah.
in the show.
Okay, before we start, can some of the new people come into the middle of the scenery here, because we are using video conference for the last speaker, and in the moment it looks like the room is empty.
Yeah,
because
you're all sitting there live, all right? Nobody's there on the camera.
yeah. So good afternoon, ladies and gentlemen. I'm happy to open the last session for today. An interesting session in terms of mobility and open network access. We will, as just mentioned, we will have 2 speakers live and 1 speaker, unfortunately, only as video conference, but this is once again shows that we are able, or Claudio is able to set up a previously unknown video conferencing system within a couple of hours. The issue, the topic of today's last session is easy access to roaming, for roaming people to networks that are around. The first topic is concerned with EduRoam, which you all know from the last session. And the speaker of this first talk, EduRoam in a Box, is Rock-Papish. Rock-Papish works for the Slovenian NRAN, and he is going to present us what they have further developed on EduRoam.
Oh, thank you, Thomas. First, I would like to ask the audience, how many of you already know EduRoam, roughly how it works? Can I please see hands, roughly? EduRoam? Okay, a few. So just to know how much to go into the details. But first, let me just start and ask you, can you find Slovenia on this map? It's the SI country. Well, it's pretty small, okay? And that, I'm saying this because, well, we don't have many big organizations connected to us. But what we have are lots of smaller organizations. For example, we also serve not only the higher education, but also different middle schools, school centers, and elementary schools. And one is of the more important customers are also libraries. Now, when we speak of the EduRoam is an international hierarchy of radio servers that allows network roaming, mobility, and it's essentially a radius protocol which is followed by a number of technical specifications. Some things are defined in an international space, and some are also defined by local requirements. So EduRoam in one country can be a bit different than EduRoam in some other country. For Slovenia, what we have is a bit higher technical standards. What we require are certain technical requirements. For example, the common use of the EduRoam SSID and the WPA enterprise protection, which means that any user within Slovenia can simply connect to different EduRoam networks by just opening his laptop. So we wanted to ensure that, and so we defined a bit higher technical standards. And we also require the hardening of the Ethernet layer. What does that mean? It means that we require that organizations who deploy EduRoam networks take care to prevent certain attacks in the Ethernet networks. For example, IP spoofing, ARP attacks, DHCP attacks. But since my talk is a bit, I only have 25 minutes to give this talk, I will not go into this topic, but the more interesting thing. Now, to set up the EduRoam in Slovenia, it's a bit more work than, for example, in Netherlands, because of all those local requirements. To set up EduRoam in Slovenia, the organization must set up some sort of identity management system, which usually translates to an LDAP directory. It has to provide suitable network infrastructure. That means access points, provide a guest network for visiting users from other EduRoam countries, organizations, networks. And what we also would like to see is the use of EduRoam for the wired access. But this is optional. Of course, there is the hardening of Ethernet I already mentioned, and they also have to set up the AAI server, the one that actually connects the network infrastructures into the EduRoam system. Okay, so the question now is EduRoam complex to set up? And actually depends on whom you are asking. If it's a big organization, they already are using wireless access points, WEA protection, know about .1Q, know about radios, then the answer is no. They just have to fine-tune some settings, change a few things, and voila, they're connected to the EduRoam. So it's easy for the big organizations. But as I mentioned, Slovenia has lots of small organizations, and we also have to provide this service to the smaller organizations. And how do we do that? Well, with small organizations, it's a big project if they're not outsourcing IT. And we must find a solution for them. So that's why we decided to try and develop a tool to help IT staff quickly adopt new technologies needed for establishing the EduRoam. Those are the EduRoam in a box goals. We want simple and speedy deployment. We don't want them to study for 2-3 months how to set up these technologies. They've probably not encountered yet, for example, .1Q or radios. And we also want to sort of provide a turnkey solution so that, for example, a smaller library could take this EduRoam in a box solution, do some things to it, input some data, and it would be running EduRoam. We also wanted to make sure that EduRoam in a box solution was not only for Slovenia, for our organizations, but to make it freely available to other NRANs or maybe to bigger organizations who try to do site deployment. So they could take, for example, Edge Room in a box solution, make some modifications to it, and give it out to certain parts of their campus that is a bit dislocated, and handle it this way. Okay. So what is Edge Room in a box? It's actually just a configuration wizard that helps configure, set up the AAI server. It's web-based, and it has to configure different Edge Room server components, which are for example, the LDAP directory. We went a bit on a limb here. We said that probably the organization who needs help to establish the Edge Room network probably doesn't have an LDAP server. So we kind of provided one in this solution. He has to set up Radius server, of course, then the SQL database for the accounting data, because we have to store the data which users, which guests were on the network. And of course, there's these DHCP and monitoring scripts, things like that. We also added tools for certificate handling, since many of the smaller organizations don't have many experiences with certificates, or this is actually their first contact with the PKI, I will say, problem. And it's very, very essential for them to have a simple tool to create these certificates and to deploy them. These certificates are the certificates for the server, not for the client. We promote the EAPT TLS authentication. Okay. We also wanted to make it easy to use, which means that we wanted to make the installation of this package an easy one. So we decided to negotiate with the local Linux users group who were providing a Slovenian local distribution of Linux, a modified Fedora core distribution, sort of an overlay. And what we did, we asked them if they could give us a repository, and they did. So we have a repository with them. So we just upload the new versions of packages, and the administrators can install them. Just when they are installing the operating system, they just install another package. And of course, the solution is open source, because we like to invite everyone to participate in the development, to test it, and maybe use it if they find it usable. So where does the Edge Room in a box solution fit? If you look at this map, it's presenting the Edge Room hierarchy. And we are trying to find, what we are doing is we are building a solution for creating this organizational Edge Room server. So what we are doing is creating this, well, I'm sorry, but I don't have a laser pointer or option to show it to you. But here, the organization A1, for example, you can see it. Maybe, can you see it?
Yeah.
This one. So this is the framework, the solution we are providing is this for the LDAP directory and the authentication server. Well, how do you set up a system? For example, you're an administrator, you install it, you want to install it, what are the required steps to do it? Of course, the first things you need to do, you need to get a PC with multiple network interface cards. That is because the solution we are trying to sell to our customers, if I may use this term, is to use the hardening of the Ethernet, which means that we want them to put a server, connect it to their network, and then connect the access point to the server. And then the server is running a software that makes it very hard for a potential hacker to run various exploits of the Ethernet network. It's a layer 2, layer 3 firewall, but it's all well hidden within the Edge Room in a box package, so that the system administrator does not have to deal with it. The thing just works. So it's a sort of a turnkey solution. And well, when he got this PC with multiple Ethernet cards, he just installs the local Linux distributions and then installs the Edge Room in a box package on it. There is no magic. He just types this simple command line called yum install Edge Room. And Edge Room is installed. The Edge Room in a box is installed on his PC. Then he just connects the PC to the wired network on one end and connects the access points on the other end into the other network cards. When he's done that, he just opens up the web browser, types in the localhost/eduroam, and he's got access to this web interface where he can configure the eduroam server. Now, the first version that I would like to talk about is the stable version. If you are interested in it, it's the one I would recommend right now. It's using the Unix versioning 0.36, and it's made for a Fedora Core 4 Linux distribution. The Pingo 4, it's actually just the local version, which the local look provided, just so we could make easy installation. It's a sort of turnkey solution in a bridging mode. Bridging mode means that there is a PC in the middle. On one side, there are the access points. On the other, there's the wired network. And the PC acts as a bridge. So it's not a router. It seamlessly plugs into the existing network. So we wanted to make it real easy. It just nicely plugs into the existing network. Okay. But it can also be used already at this version for also more complex settings. One of the examples I wanted to point out was the Central Technical Library. They deployed it in this way that they used it as the eduroam in a box bridging solution. But then they said, we don't want to do bridging. We have layer 2, layer 3 security on our switch network. We don't need this. We only need a server. And we also have some special requirements, which were that the guests, the visiting guests from the University of Ljubljana have access to Elsevier, and the guests from other parts of the world, of the eduroam world, only have access to internet. And this is what we've done. So they just took the eduroam in a box solution, they set up the basic system, and then they customized it by hand. And it's much easier to customize something that already works than to make it out from scratch. We also did a lot of testing with this currently stable version. We did quality assurance, meaning we did in-house testing to find bugs, to find cases where you input wrong data and things don't work, for example. And we got quite a lot of feedback. We also did usability testing. That means we found a few coworkers who were not very technically experienced, who did not work with networking. And we just gave them the interface and said, okay, now you try to configure it. And then we were observing what they were doing, how they were progressing. So we got a lot of internal testing. We also got quite a lot of external feedback from the deployments, which things were great, which worked great, which things were not great, or where there were some maybe wishes to provide more functionality. So we started work on the newer version, 0.4 point something, and this version is already heavily in development. And what we did, we simplified the interface, because one of the usability tests said that the user interface, it's okay for regular system administrators, but maybe it could be done simpler and more intuitive. So we've done some work on that. We've also added more functionality. Since the Central Technical Library said this is a great product, but we had to do some things manually, which we maybe wouldn't have to. So we said, okay, we can provide some more functionality. And one of those were the standalone version, so that the new version of eduroam in a box will also work just as a standalone server, nothing special without the Ethernet hardening if you don't want it. We also will add, this does not exist yet in this version, the support for network address translation, so it will be able to use the eduroam in a box solution when there is a shortage of IPs. And we also decided to use a smarter framework, so that the application is aware of different components, different services, the LDAP, the MySQL, the DHCP, so it's aware which of those components it must restart, refresh the configuration if the input data is changed. So it got a bit smarter. Okay, and this is a few screenshots so that you will know what I'm talking about. For example, here you can see it's a screen grab from the web browser, and you can see the configuration of DNS servers. You just input the IPs of DNS servers, Just go commit, commit, commit. When it's done, then you go to the commit changes at the bottom, and it will tell you which things needs to be committed, and you can do it then. I'll just show a few screenshots here. For example, here you configure the type of the server you wish to set up. Is it a standalone eduroam server, or is it this eduroam server that's using maybe NAT or bridging hardening, for example, the Ethernet hardening? And one of the things we are kind of evaluating is, do we want to offer support for open network access with web redirect? This is still in the process of evaluating. Do we want that? On one hand, we don't want to, but there is a need to cover special events where guests don't have the eduroam username, and we might wish to issue temporary usernames for access to web redirect. This is one of the screens when you configure the peering radio server. So if you remember the picture we had of the radius hierarchy, there was the organizational radio server, and there was the upstream radio server. Here you configure the upstream radio server. And like I said, the last screen is the commit changes. Here you can see when user inputted his data. Then he goes to this screen, the commit changes screen, and he can view which modules will need to be restarted. Modules, services. For example, if you change the subnet, the DHCP server needs to get his new configuration, needs to be restarted. So these are the components I was talking about. So, a few words about the future. Well, the first thing, you should never predict the future. And, of course, as every rule needs an exception, eduroam in a box will be, as it is now, cool. And what we're trying to do is also to think what functionalities we might add to eduroam in a box. For example, the access point database, statistics, things like that. There's a lot of open field. Right now, as it is, it's a very usable product, but there are so many other things we are thinking about adding. And one of them, of course, is eduroam in a box demo site. Okay, questions?
Yeah, then let's first of all thank the speaker. And other questions, comments from the eduroam or not eduroam community? Then let me put a question. How many of these boxes have you deployed? Have you in place?
In stable environments, there are 3, and there are 2 development machines, networks.
Mm. And are you planning to access new groups of customers with that too?
Yes.
Mm-hmm.
That is actually what I'm doing here. I'm trying to promote this project so that other entrants might find it interesting. I already had a talk with Croatian colleagues about it, and there's been some interested customers from the UNIC and from SurfNet.
Yeah, I was also asking about customers, I mean, inside the country, like outside universities or so.
Well, the eduroam in a box solution is aimed, of course, at my customers primarily, or the education and research community. But in itself, the package is also useful for other radius-based wireless networks. It's not a must to be connected to eduroam, so it's quite usable. But no, I've not been researching this.
Okay. Other questions? There's
one. Very interesting project. I have just one question because I was a little bit late. If I get it right, we can talk about it also later. So you have the access points connected to a box, and then you do the authentication of the users, transmit to a server somewhere in where you are, and so that some guy who is authenticated within your system is also authenticated on other systems where this eduroam's system is standing then, right?
Yes.
And though you provide internet access or whatever access to some users somewhere in the world if they participate in your project.
Yes, exactly.
Okay.
But it's not the project, it's the eduroam federation. It's the eduroam hierarchy.
Yes, I will come to you later. Okay. Thank you.
Okay, then let's thank the speaker again. And we will come to the next related but not EduRoam project subject. This is the OBAN project, an open broadband access network. And this talk is brought to us by Herbert Almus. Most of you will probably know, but I will nevertheless introduce Herbert Almus. He is almost ever since deputy head of the Interdepartmental Research Center at the Technical University in Berlin, but he's also one of the first pioneers in broadband networks. He's working since the 80s in broadband networks. 88. He's also the father of the European Advanced Network Testing Center in Berlin, the EINTC, which is now a successful company operating internationally. Is that right?
Yes.
Okay. So we have a second for the audio here.
Mm-hmm.
Do you want to start with a flash? Or?
Yeah, I will start with a short animation, which is a flash application, and hopefully we get the audio too.
Open Broadband Access Network.
Do you hear that?
Do you hear something?
Development project funded by the EU's Information Society Technologies Initiative of the 6th Framework Program, the Swiss Bundesamt für Bildung und Wissenschaft, and the project's partners. While today's narrowband mobile networks are evolving towards broadband, the number of base stations and associated feeder lines will increase dramatically. The next step from today's UMTS will require optical cables in the feeder network, and the granularity will become comparable with that of the fixed access network. At the same time, the fixed access network is being upgraded with DSL technology and optical cables, evolving into a high-capacity broadband access network for millions of users countrywide. Most of these households and businesses also use wireless LANs for in-house networking.
Blue bubbles are wireless
The
LAN.
extended use of wireless LANs, as well as the growing bandwidth demand in mobile networks, is leading to a convergence of both, not only in regard to radio coverage, but also the demand for high-capacity feeder lines. Since wireless LANs are often unprotected and extend beyond home and office areas, casual passers-by can easily connect to these networks without the owner's knowledge. On the other hand, if they are protected against such intrusion, they will not be accessible to the public. The OBAN approach is to keep these radio LANs open for public use in a controlled way. Fixed subscribers can continue to use their network as before, without noticing other people connected to their network. Mobile users will experience a borderless broadband network, a network offering real broadband capacity equal to what they're used to at home and in their offices. OBAN aims to integrate fixed and mobile networks, opening up vast new realms of activities and opportunities, and allowing passers-by to use the available but unused transmission capacity in wireless and fixed network infrastructures. The OBAN approach provides broadband services by using existing and rapidly expanding networks instead of trying to upgrade the narrowband mobile network to a broadband network. The project will make it possible to exploit the unused capacity of both networks, rendering additional costly investment superfluous. OBAN is based on the principle that most of the available transmission capacity in the access networks is not being used. The idea is to make these resources available to casual visiting users. Wireless LAN access points are connected to a residential gateway, providing connectivity to both the owner, in this case Mr. Stationary, as well as public access for casual visiting users, represented here by Mr. Busy. The residential gateway ensures that Mr. Stationary gets bandwidth and service quality according to the terms of his contract with his service provider, even when multiple visitors are using his network access. During their meeting, Mr. Busy uses the O-band services by sharing Mr. Stationary's infrastructure. Based on their contracts with the O-band service provider, it is possible to experience immediate, hassle-free shared network access. When he leaves his office, Mr. Busy stays connected, safe in the knowledge that he can continue to use network services, since the technology and administrative and legal arrangements of the O-band system ensure automatic switching to the next wireless LAN access points. The O-band network provides seamless handover without re-authentication and service interruption in compliance with privacy requirements and other regulations. Mr. Busy can roam the streets while maintaining his connection. When Mr. Busy enters an area without wireless LAN coverage, his connection will be seamlessly taken over by an available cellular network with minimal impact on his service quality. Likewise, when he re-enters an area with wireless LAN coverage, he is automatically switched to this network without any service interruption.
So this is the O-band vision, and I will talk about many details later. We'll continue.
During his ride to the next meeting or conference, Mr. Busy may switch to wireless networks which are being visited by other O-banners, who may just be enjoying the nice weather while using internet access provided by O-ban. If we assume that the average broadband user transfers around 10 gigabytes per month, only 3% of the available capacity is used. 97% remains unused. O-ban creates the conditions to make this huge unused capacity available to passing or visiting users. For the O-ban vision to become reality, the project will continue to develop solutions for network access, mobility and fast handover, as well as quality of services and security. The O-ban project also carries out research into business models, regulatory issues, and estimation of network coverage and capacity. O-ban will open up completely new market opportunities for network and service providers to offer new and improved services.
So this was also the list of the partners. So this video was more or less a vision, an idea, and the idea beyond O-ban explained a little bit. So the idea is that we really use private available wireless LAN or wireless access capacity for visiting users or users passing by. And we do this without disturbing or reducing the services that the regular broadband access user at home, the private user which is using his ADSL connection at the moment, is suffering from this additional usage. So the idea beyond is that normally the user who is running an ADSL contract or has an ADSL contract and is using his broadband access, he uses maybe 1 or 2 megabit, but on the technical base, in most cases, 8 megabit, for example, on regular ADSL technology is available. So the idea is to use this bandwidth to the ISP, this additional bandwidth to the ISP for the visiting users. And of course, you can set up, for example, an additional wireless LAN access point to serve bypassing users. So then, of course, let me just say this is a project funded by the European Commission, and there are a lot of carriers involved. So it's beyond is also a commercial idea, but there are some aspects, technical aspects, I will talk a little bit and the focus will be on both, which are also maybe useful for things like considering mobility in EduRoam. Mobility in the sense that you keep connectivity while you are moving and switching to the next access point, not just as a fixed solution where you sit on a table. So seamless handover support is also integrated part of the O-Bahn project, and we have to support voice over IP, for example, and over VLAN, and we also have to look at location-specific services. Of course, you can do a lot with them because you really exactly know the position, so the coordinates of the residential user are well known. Let's talk about the broadband access today. As already mentioned, we are using only parts of the available capacity. This is true for ADSL, ADSL 2+, for example, as well as VDSL technologies. This is also true for cable modems. We may have at some time fiber cable to the home. Wireless technology may be used for broadband access. But this may be even used extended. So if you think about the VLAN, which is now used by the visiting users, this could be also in the future be a WiMAX technology for home installation. So, and of course, there is a big potential beyond this approach because in Europe, we have, at the end of 2005, we had 23% of the European households connected via broadband access technologies. And in Germany, for example, end of 2005, it was around 10.4 million connections, which is 27% of the German households. So most of us are not really using this access at the whole time. So as already mentioned, if we are using maybe 10 gigabit per month, there is a lot of bandwidth available. So think about the potential. There is, just let me say it the other way around. There was a discussion yesterday in the morning when Michael Nelson talked about, okay, what do the conventional carriers, which have just to struggle with the old telephone system, where are the market opportunities? We do have an access technology which is really not in use. So 3% of usage is nearly nothing. And if you compare it to the technical available capacity, it's even not a person. And the number 3% is, at least by 2 people I know, which are working for telcos, confirmed. It is even less. So we have a lot of access technology. Maybe we have to extend the backbone, but we have to have a lot of access technology available which can be used and is really there to be exploited for usage. As already mentioned, and therefore I will skip the slides or just mention it again, we see that there is a convergence. So we need stronger feeder lines. The cell size this was already mentioned in the demo, the cell size on the mobile networks will decrease. With UMTS, you cover less. With the next generation of broadband access for the mobile networks, you may even cover a smaller area and so on. So if you look at the bubbles, you see we have small blue bubbles. We have increasing blue bubbles by WiMAX and technologies and things like this, but we have decreasing size of the red bubbles in the mobile areas. So let's talk about a little bit more about some technical details now. If you think about the O-Bahn model, which parties are involved? There is, of course, an ISP of the visiting user, then the internet service provider of the home user. Then we may have a different access network provider, and we, of course, have the home user, which is sitting in the home, which has a residential gateway. Just to let you know, in O-Bahn we do a pilot implementation, and in this pilot implementation, this is a mini ITX PC, so a small, not very powerful PC. This is sufficient for the requirements. And we, of course, have the access points and the visiting user, which is passing by or just sitting outside normally. So these are mainly the parties which are involved. What have we do to provide the additional bandwidth for the uplink and downlink to the internet. Okay, that's relatively easy. We have to this by a simple bandwidth management. So we have to set up, for example, in the DSL scenario, 2 data passes with fixed, well-defined access rates. No problem at all, or shouldn't be a severe problem. You can do it a little bit more sophisticated. Then you, of course, have to strictly prioritize the traffic of the home user in the range of his rented bandwidth or transmission rate. This is one of the reasons, for example, why the O-band approach is a provider-oriented solution. So you can't do that without including the access network provider and so on. Other solutions which are on the market, like Boingo or whatever, they don't use the now unused capacity. They just extend the usage or extend the user group by sharing what is already used regarding the access lines. Within O-band, there was also a demand to support quality of service. This is done, and this is in between already implemented. It is now integrated in a pilot or portable demonstrator. This is done based on 8.0.11e, the multimedia extensions. So we have introduced an O-band quality of service broker, and he knows about the capacity of the access network, and he does traffic policing, for example. We carefully monitor what happens at the access point, and an O-band user has some capacities. He has a QoS profile. This maybe just take a simple approach, gold, silver, bronze, or whatever profile. And these profiles are managed by the QoS broker, and they can be part of or stored in the authentication server or things like this. But this profiles has to be managed, and this will be done by policing the traffic. For example, if you have 3 O-band users as a wireless access point, then you will normally, if they have the same quality, you will equally distribute this. During the whole time when they are working, the conditions on the wireless access point may change. Yeah? The transmission capacity, the total transmission capacity will change, for example, if users go further away from the access point. So you will see we have continuously changing conditions. They will continuously monitored, and we will take care about an adequate redistribution of the bandwidth. In addition, we have something like an admission control. So if we can't promise or can't provide the quality we assume, or which is asked for because of the profile of a new user who may tries to join, then we may not accept it. And things like this are handled with the quality of service broker. So there is a sophisticated capacity distribution algorithm who takes care for this. Mobility. As I mentioned already, one of the goals is to provide mobility. Mobility in O-band is limited to a speed of 15 kilometers per hour. But if you support mobility, of course, you have a lot of problems or a lot of other aspects to solve. For example, the change must be smart. It doesn't. It has to be fast. So we have to provide a single sign-on possibility. Just to give you an idea, this is at the moment solved. Okay, let me say it the other way around. The first authentication in this O-band scenario is normally not time critical. It can take seconds. Nobody cares about it. But if you are first authenticated and then you roam to switch to another wireless access point, and for example, you try to continuously use your service, this has to be done fast. For the first authentication, we are using an ARP SIM approach, and we have developed, this is mainly done by Motorola, developed a solution where when you are sitting on your notebook and you are logging into an O-band scenario, there will be set up a Bluetooth connection to your mobile phone, the ERP SIM mechanism. Your SIM card will be used for the authentication purpose, and then you will authenticate, and then you can log in. So you don't have to touch the phone at all. So it's really simple. Again, when we change an access point or even a network, that may be just even another IP service provider on the next O-band access point, then we have to take care that we do not have an interruption of the service. And how this is done, I will explain a little bit later. There are, of course, other aspects. What about visibility? Who has access to the data? If you, for example, provide your wireless LAN access point to a bypassing user, then of course you may want that he doesn't know your identity. And the residential user, the home user, doesn't have to know the identity of the people who are passing by. So there are a lot of laws, if you run this as a commercial service, which cover those aspects. So how can this realized especially in an environment where we have 25 countries in Europe with different laws regarding protection and things like this? I will give some example later on when I talk about a fast method for re-authentication, where one of the solutions is just not applicable in all European countries because of those laws. Another aspect, if you run a system like this, is that now equipment, which normally is managed by the carrier and which is a sensitive component like the residential gateway, is placed in a private-owned environment. So the home user could try to fake services on the O-band wireless LAN access point and forward modified data or whatever. And of course, a visiting user could try to interconnect to the private network of the home user and things like this. So you have to strongly separate this and you have to do a lot regarding to ensure the proper operation of the box. That is one of the aspects you have to consider if you try to set up such a service. Mobility handover is the most or the biggest challenge in the project. We have to support interactive multimedia services with video conferencing and voice over IP. And one of the project objectives written in the contract is that we have to reach handover times less than 120 milliseconds on a wireless LAN. This is really difficult. If you think about the performance for a handover in a wireless LAN, we are talking about seconds. If you are, in addition, do this or consider this on IP layer, we are talking about 8 or 10 seconds, for example, if we are using mobile IP, as we have to do. So the consequences are that we are, and then think about re-authentication too, that we have to really work on this and find methods where we definitely can reduce this handover delay. And another aspect, just to mention it, if you think about GSM, UMTS networks, there you have the possibility to do a make before break. You can do a connection to the next access point before you leave the other ones. On a traditional wireless LAN environment, you can just not join the next access point before without leaving the old one. So the mobile IP, and we have to encrypt the data and we have to separate the data as I mentioned. So the mobile IP solution has to be compatible with common encryption techniques. And the handover process has to include re-authentication. And of course, it has to be done automatically. So one of the consequences of this is that an O-band terminal needs some additional software. So you will not can or will not be able to realize this without running some additional software on the terminals too. Let's think a little bit about how to minimize the wireless LAN handover delay. Code optimization alone will not be a solution at all. What we can do and what we will do is gathering a lot of knowledge about the environment. So this is not mentioned on the slide, but this knowledge will be distributed by card protocol. So we will have a card server and card proxies in addition to distribute this kind of information. So we have to avoid painful DHCP, things like this. And one of the approaches is that we, for example, the client does a background scanning all the time. He gets an information, therefore, about the signal noise ratio and condition about nearby access points. The mobility broker functionality we implement knows about the neighbored access points, knows about the frequencies which are used, knows about, of course, the SSID, knows about the quality of service available because of the use on the other nearby access points, so that there is no seek before for the next access point, and there is even, under normal conditions, if an access point is available with sufficient quality of service, we can ensure that the right access point, the best access point nearby, which is inside for the terminal, can be used by the terminal. This is just integrating or using the information about the neighborhood. But we do have, of course, do a re-authentication. The terminal, which joins the next access point, has to be identified. Full authentication would take too long. So what we are doing, we are using a Kerberos approach. In principle, we have a full authentication at the beginning. So the mobility broker knows the identity of the terminal, and the first residential gateway, of course, knows the identity of the terminal 2 because of the ERP SIM mechanism with the SIM card and so on I already mentioned. Later on, we are using shared secrets in a way where parts of the secret are known or can be proven by other entities. For example, we have a shared secret which secures the information flow between the mobility broker and the client, the terminal. And in addition, there is a shared secret between the residential gateways and the mobility broker. And this shared secret between the residential gateway and the mobility broker allows the residential gateway to check the secret which is provided by the terminal. And therefore, the residential gateway can do a local decision, okay, this guy can join. So he's authenticated by the mobility broker, and I get a separate information which allows me to prove that this is really the person I expected, and he even can do this without the full knowledge of the identity of the client who is joining. So this is in principle the approach chosen. When we evaluated possibilities to do this fast re-authentication, we had 3 different approaches under consideration. The one was, a simple one was a delayed authentication, where we just say, okay, let the client join, but only for a limited time. And during that time, he has to do a full authentication to the AAA server. This is not allowed, or at least you have problems if you are running a service as an ISP. For example, in Norway, you have to really give a red flag to the user that there is an unsecure condition and so on. So this may be an acceptance problem. In some countries, it may be not allowed at all. Another idea was to do a mutual authentication between the terminal and the residential gateway in conjunction with so-called trusted point approach. I will not go into the detail, and I'm not an expert on authentication at all. So the use of topographic knowledge I already mentioned. So to prove the concept, or just again, we implement parts of the solution. So we don't, or it is not the objective of the project to provide a full solution to go into a business or to be used in any way. But it's a demand that we prove the crucial functions. So we have to show the fast handover, including authentication, including the security aspects regarding privacy and things like this. Therefore, we have a field trial, which is running all the time during the project phase. The project is a 3 years project, which will end at the end of this year. Then we have a test bed to evaluate functions at the Technical University in Berlin, and there will be a concluding field trial in Paris, starting in October, November timeframe this year, to test the integration of those functions separately developed. Of course, there will be some integration testing before. We do have a so-called portable demonstrator, which is used to demonstrate functions like, for example, that we already can do quality of service handling and things like this. There are some applications where we can also visualize the effects. I mentioned at the beginning that some aspects are also things like location-based services. So if you think about such a solution, you can extend, of course, make an extended offer regarding services to the participating home user, for example. He could announce garage sale on his access point and things like this. So we are using something like called IP zones. So we have different environments for the home user and the visiting user, and this could be also make it possible that the visiting user has an easy way to, for example, access his computers or servers at home or things like this. Even a print service, you could think about it. If you are at home and somebody who is passing by may need a printout, why not? There was also mentioned in some part of the Flash animation that, for example, if we change or have changing conditions, that we will be able to adapt services. Of course, this is not true in general, but we have a SIP-based, user agent-based solutions where we, for example, can adapt the codec, change the codec to be used on a video stream and adapt the picture size without reconnection, so that we can really adapt to a decrease of, for example, bandwidth available on the wireless LAN. A practical evaluation, for example, of voice over IP. If you are moving, it's really difficult. It depends on, sometimes seems to depend even on the systems you are using, but if you are moving slow, this is possible with acceptable quality. So looking at this additional services is another thing, but the main problem is secured connection, the smart re-authentication which allows fast handover, and to find a way to use location-related information or neighborhood information to allow a very fast handover even on IP level. Okay, these are the project partners, and there is a lot of information available on the public web of the O-Bahn project. I think there are 10 deliverables, thousands of pages, at least 1,000 pages of information, business cases, feasibility studies, and things like this. So whenever you are interested in some more details about the project, just look at the web page. And thank you for your attention. And now I'm
thank you very much, Herbert, for this very interesting talk. Questions? Here's one.
in your model, your system, you mentioned you are considering IPv4 mobility. Do you consider IPv6 mobility also, or not?
Yeah, we did, and we should have chosen it, frankly spoken. But at some point in the project, it was decided to go to mobile IP4. We would have less problems in some areas if we would have chosen mobile IP version 6. But it just didn't take place. Does this answer your question?
You are planning to consider IPv6 mobility also? Or not in the...
Not within the project time now.
Mm-hmm. Okay.
No, sorry.
A related question: what is the opinion of the providers you have in your boat? Are they hesitant towards mobile IPv6, which really can do handovers in times less than layer 2?
Yeah.
Or are they just keen on getting this?
I really can't answer the question. So yeah, because there was a discussion about it, but this was also driven, sometimes it's driven by pragmatic decisions in addition. So for example, because one of the partners has a mobile IP solution which provides a lot of those aspects already, which you are using and you really need. Yeah? For example, that you can use encryption mechanisms, VPNs, IPsec tunnels, that you have a possibility to terminate those tunnels within the mobile IP scenario so that you can really transparently use it, and things like this. So for different reasons, this was decided. I was always not excited about it, but okay.
That's the way it goes.
But I don't have a strong meaning regarding telcos about it, so I can't really answer your question.
There's a question, and there's another one.
So when you have the access point gateways, which is the open gateway, here,
Oh.
in front of you, here.
Okay. Sorry.
The open access point gateway is total under your control, and not the home user cannot touch or modify or do anything with it. And should not.
In a solution where you really use it in a commercial environment, you should not be able to touch this or to modify this piece of equipment. This is a replacement of your conventional DSL router you are using now. And so this has to be assured that he doesn't have the possibility to destroy the integrity of this device. That's right. So, but if you think about commercial deployment, then this device would be just a product.
And
should be possible.
When you say about commercial usage or in enterprise systems, what are the enterprises talking about this? What do they think? Do they want that? I mean, if there's in open source communities, there's dream walking by using and do whatever you want to do over public wireless environment. But normally, this is only possible in private usage. What do the enterprises see?
I'm not sure if it is really possible in private users. So if you are running a company and you have access, then it's of course different. But if you think about what an ISP has to provide, then normally you would accept if I go to a hotspot that I don't have any limitations. And why should I expect this if I use just a private access point of a residential user? So of course you have to tunnel it, you have to ensure that you don't disturb or that secrets about the home user are not exploitable or whatever. But in principle, the ISP service provider is open-minded in the sense that he has to provide anything if possible. So that's not a problem. So in eduroam, as we discussed here, I will ensure, and we have maybe some user I trust a little bit more and some I trust a little bit less. This is not the scenario which an ISP is normally struggling with. Right?
Okay.
So last question. Yeah? Yeah.
Yep.
Are you also waiting? Yeah. Okay.
Yeah, I'm waiting too.
Okay, then go ahead. Yeah, and you are the last man. Okay.
Yeah, I'm from Norway, which you mentioned briefly. Well, you didn't say anything about accounting. One of the problems with, well, not ISPs, but at least with cellular phones, is that you have no idea what the cost is when you go abroad. So if you have a system like this with many ISPs, what is the cost and how do you know how much it costs where you are right now?
Okay, I didn't talk about it because this is beyond the scope of the project. So we are really not thinking in detail about it. Of course, all the traffic of the visiting user is tunneled to his ISP. And you have, of course, to have roaming agreement, and you have, of course, to ensure by the residential gateway and the integrity of the residential gateway that you, for example, have reliable information about the use, if you are not talking about flat rates or whatever. So this has to be done in the same way it is now done, for example, in mobile networks. If I'm using UMTS or whatever and have a data connection from here and I have my provider in Germany and I'm using the connection, then they have to care. And regarding the O-Bahn project, this is really beyond the scope of the project itself. Sorry, not that we didn't do any research on this.
So, last question.
So the idea of using the unused bandwidth is very interesting. And as you mentioned, there are many and many more ADSL lines which have the 8 gigabit bandwidth. However, I do see a competition between your service and another one which is currently emerging on the market, which is related to the triple play service. So there are operators which are aware of this extra bandwidth and which are using it in order to offer IPTV or digital television. So do you think that the project may survive in relation to the deployment of those services?
Frankly spoken, no idea. This is, of course, there are other possibilities to use this bandwidth, and the one you mentioned is, of course, the exciting one which is now considered. So I don't know. And frankly spoken, I'm even not sure that we will really see the O-Bahn picture as I showed it now up and running. Yeah? But nevertheless, think about the background of such projects. It makes sense to investigate in those aspects too. Because even if you don't have a multi-ISP server environment, it could make sense, for example, to support fast re-authentication. So results of the project, and this is also a little bit funding the economy, those European community projects, make sense too. So there are, maybe we will not see the final result. I would be happy if I see it, because I think if it would really come up and running, I would appreciate it, because then maybe I just passing by and my download is ongoing, and I look at the on my mail when I sit down the next time or whatever. This is difficult. I'm from the university, but at least I know that some of the telcos which are involved are really doing additional research in some aspects of those which is covered in O-Bahn. This gives me an idea that a part of the O-Bahn vision may be implemented and available at some time in the near future. But again, I'm a scientist of the university.
Thank you.
So let's thank the speaker again, and thank you for the interesting discussion. We are following with the last presentation, which is closely related, but here we have a highly mobile speaker. The speaker is Carsten Bormann. Professor Carsten Bormann. He is one having a home location. This home location is at the Technology Center of the University of Bremen, but now he has also a current location, and this is he's visiting professor at the University of Helsinki, and he's brought to us via video, so he has even a third virtual location. Carsten is very active in the IETF, chairs several working groups, and is let me put it that way, is a senior expert in advanced networking technologies. Can you hear me? Can you see the audience?
Well, I can hear you very well, Thomas.
currently not seeing the audience, but a copy of my slides because I will have to give commands when they are advanced. So it's better if I see the slides. But I've seen the audience before.
Okay. Then the floor is yours. You're speaking about enhancing user mobility within network service maps.
Okay, I gather you can all hear me?
Yes. Yep.
Very good. So this is a pretty strange talk because there are three people involved. Dirk Kutscher, who's currently in Tokyo, Jörg Ott, who's currently in San Francisco, and I'm currently in Europe. So I actually got to present this talk. And I apologize that I couldn't come closer to Catania than going to Bremen, but I hope this will still be a useful talk for everybody. So, second slide. The basic problem we are looking at here is pretty much the same problem that Herbert just detailed. We have lots of different ways to connect to the world right now, and the map you see here is just one map of the WiMAX network rollout in Japan. And we have lots of technologies, and the general assumption is that we will get more technologies. Old technologies die out very slowly, and we get new technologies out there. We have overlapping coverages, we have competition, and so on. We have different prices. So how does somebody who moves about and wants to start a network connection find out what to do? Next slide. And as Herbert said, of course, the addition of all those wireless LAN hotspots doesn't make life easier. So we now have all these places that by providing the SSID somehow advertise they provide some services, but we don't know what these services are. So next slide. This is what we see today. We have a wireless LAN zone somewhere. This is in the airport of Stuttgart in Germany. And then we have three providers here, T-Mobile, O2, and Vodafone. And you actually, as a user, have to find out which of these three providers you want to use. You maybe have to read their web pages to find out what is going to be the cost of connecting, and so on. That's not a very nice situation for a user to be in. Next slide, please. So one thing you can do, of course, is before you travel, you look at the web page of the provider, look up what kinds of hotspots do we have, and maybe select your location, or look up whether you will be able to use the network or not. Next slide. And then finally, when you are in a specific location, you can look at different networks and have to decide which one to use. And again, this not only applies to wireless LANs. We are getting more and more different types of networks. Some actually are unidirectional, some have free access, some are access controlled, and so on. So the question really is, how do we handle this situation? Next slide. One additional thing that comes in is that this is not about network access. It's not just about getting bits across, but different providers may actually provide different additional services. So for instance, one provider might provide a Wi-Fi voice service, and it may be useful to find out which service that is, what is the local proxy, what is the actual functionality that will be provided over that environment. And network access is just a specific service amongst others. So you don't only want to know, do I get to the internet? You also want to know, what is the service that this specific provider is providing me in this environment. Okay, next slide. So this scenario actually applies in quite a number of different environments. We are all familiar with a campus roaming environment where you go to a different place and you have to find out what exactly is the way to use EduRoam there. do I use web-based access, VPN, or WPA-based access? What is the SSID today? And so on. And of course, you also want to know when I go in there, what is the kind of access I actually get? So is it just internet access? Are there going to be restrictions? Do I have to consider some acceptable use policies and so on? Now the second scenario we are looking at is the nomadic use of public wireless LAN hotspots. The situation the pictures were about in the previous slides. So you go somewhere and try to find out which wireless LAN hotspot is there, and you essentially want to automate all the work that currently needs to be done by the user. The third scenario is the shared use of private wireless LAN installations, and we have just heard a talk about one approach to doing this. Still, you may want to see different providers providing these private wireless LAN access solutions, so that there is not only, say, a T-Mobile-based access based on O-band, there is also phone, and there is SOFANET, and so on. The fourth scenario we're looking at is closed networks. You may be entitled to actually use the closed network of a particular company, and when you are moving, you may actually see a hotspot provided by that company. So you want to integrate this information into your personal network service map. And finally, you really want to do all this quickly. You don't want to have a lot of manual interaction. You really want to have this go on automatically. And if you have information on where you will be going, such as in a car, when you have a navigation system that already has the information where you're trying to go, then that information actually may be useful for planning the further wireless access that you want to use. Next slide. So specific to Terena, we know about EduRoam. We have this wonderful mechanism for doing nomadic wireless LAN access, but again, there is diversity, and knowing the way technology goes, the diversity is not usually getting smaller as time passes. We have different authentication mechanisms. So if I'm at a site that provides both web-based access and WPA access, which of the two do I use? Are there maybe different service restrictions on these two mechanisms and so on? And I really want to find out all this information when I'm at the location and want to use the network. So it would be useful to have information in something that we call service maps. Where are the EduRoam networks that I may be able to use by traveling? When I have traveled somewhere, what are the authentication mechanisms that I can use right now? What are the local services? Maybe even where are the access points? So if my network doesn't work too well, I can find out where I can move to get better reception. And these requirements are pretty well known, so the Terena Task Force Mobility has actually started collecting requirements in an access point phone book activity. Next slide. So all this, of course, is not a new problem, not a problem that we have discovered yesterday. So other people are working on different approaches to provide information services about networks. And IEEE 802.21 has defined a network information service for the single purpose of supporting media-independent handover. So you can do handover from, say, WiMAX to Wi-Fi and then to UMTS and back to Wi-Fi and so on. So in this case, what you really want to find out is what networks are there, what are the access-specific characteristics, what are the things that need to be done to connect to a specific network. So the media independent information services provided by .21 are pretty focused on this handover aspect. There are other approaches out there. The IETF is working on something called candidate access router discovery, and there are lots of approaches on optimizing mobile IP in this environment. And the Wi-Fi Alliance has defined something called a smart client, which also would be able to automatically use information that is available. Next slide, please. So what we are trying to do is bring all these types of information together in something that we call service maps. So we have an information service that provides all the information that the users want to know, or that their automated agents want to know for selecting networks, for doing the specific things that the user wants to do. One important aspect is that there is no one-size-fits-all here. You really have to have different ways of providing and receiving this information. So some information will only be able to be filtered on the receiver. Some will have to be filtered in the infrastructure. And we want to accommodate different network architectures while we do this. So the main idea is the mobile nodes receive service information, and they can actually request service information from different sources, and they construct a network service map according to the requirements of the mobile node. And what we are doing right now is focusing on the transport layer aspects. Of course, there are some pretty interesting aspects up there in the financial and political layers. Next slide, please. So this is just visualizing what an environment might look like where we want to use this. We have 3G, UMTS, HS, DPA, and so on. And we have maybe some big yellow WiMAX zones, and we have a couple of small yellow wireless LAN zones. And we want to find out what is the best thing that the mobile device can do right now to use all this infrastructure. Next slide, please. So the basic idea is the mobile nodes receive service announcements from multiple information services. So these services include information such as positions or scopes where all these announcements apply. And the mobile nodes construct a regional service map of the services that are available in their network neighborhood. And this is independent of the specific network, so you don't really have to have one network just announce the characteristics of this network itself. You actually can provide information about other networks, about other operators, and since the mobile node actually can request such information, it actually can complete its local service map from information that it may not be able to find in a broadcast. So what we need is different interaction schemes, different transport mechanisms. We need broadcast, we need pre-response. We may even need subscribe notify to find out when things change. And given that these characteristics are probably going to pretty big databases, we actually have to do this in a scalable way. And we have to understand that we cannot come up with a single database schema that will work for the next 20 years. So extensibility and specializability is a very important aspect here. So the broadcast may provide you some general information, and then you, after you have used this general information to make an initial decision, you may want to specialize this information after selecting. Next slide, please. So what happens is we have different sources of information. We have maybe a digital broadcast, let's say on DVB-H. We have regional information services. We have information from local hotspots. Next slide. And what happens is that the mobile node constructs a service map from all the information that is available. Next slide. So the architecture behind that is that some of this information comes in using a local broadcast. So when you come close to an access point, this access point not only broadcasts its SSID, you can find out additional information from it in the form of a service map, but then other information will have to be requested from the user device using some query response protocol. And very important, the local provider that provides this broadcast of course, doesn't necessarily know all the changes that have been made by ISPs that provide services. So the local provider who's providing the aggregated broadcast may want to use subscribe notify to combine information from different sources. Next slide. The underlying mechanism is the Internet Media Guide mechanism, where we have different ways of transporting this information. So we have announcements of full maps, of deltas. We have a query resolve mechanism, which is the HTTP-like pull mechanism. Again, we can request full maps or we can request deltas. And we have subscribe notify. Subscribe notify can result in full maps, deltas, or, this is the green example, in pointers that then in turn can at leisure be used by the receiver to query and resolve the information that is required. Next slide. So what we need is a couple of transports to actually transfer this information. For the announcements, it's pretty clear that Reliable Multicast provides an answer here. So the protocol is Flute, and Muppet is a specific mapping of this protocol to Internet Media Guides. For Subscribe Notify, for instance, we can use the SIP mechanisms for subscription and notification. For Query Resolve, quite obviously HTTP is a good way to do this. And to identify all the data sets in all these transports, we need something that overarches all these transports, and we are using Internet Media Guide URIs to identify those data sets. Next slide. So, oops. So the one issue is the transport. The other issue is how do we structure the data that actually is transferred in these data sets. There are a number of requirements. First of all, we need to be able to uniquely identify the services and the service providers. We need to talk about locations, either in GPS coordinates or maybe in the form of civic addresses. So if I know that I will be doing something in Catania, maybe that's a good way to identify the location instead of first having to look up the GPS coordinates. All of this needs to be searchable. We need to be somewhat application independent here, so the aggregation and filtering that may be done somewhere in the network doesn't have to understand all the details of all the specific applications. As I said, we have to be extensible because we don't know what the requirements will be, and we have to be reasonably efficient. So the implementation that we chose is an XML-based format. XML provides some very nice extensibility mechanisms, namespaces, and so on. And XML also provides a lot of existing vocabulary, like the geographic markup language, that we can use in order not to reinvent the wheel here. We also use a tagging concept to have some informal classification of services. Next slide. So the result is that we have different data items. We have an envelope that identifies where the information is coming from, what is the scope, what is the version. We have a number of locations being described by this data set. We have a number of providers, and we have a number of services. And these are actually factored out because all the service instances probably share a lot of information. So it's very useful to have separate data sets for locations, providers, and services. Next slide. And the actual service instances then essentially just reference a location, reference a provider, and reference a specific service, and also contain a URI using which the device can actually get refinement information that goes beyond this. So when a service has been selected, for instance, the device can find out specific information such as channels or acceptable use policies or things like that. Next slide. This is an example of such a refinement, a piece of refinement information. For internet access, you might want to know the specific authentication method being used. Next slide. So when a user device moves around in the world, it will see all kinds of different broadcasts for information. It will maybe use the web to access more detailed information, and from that it actually will build a service map with all the information that then can go into an automatic selection process. Next slide. You're not supposed to be able to read this. This is just to motivate you to look into the paper and see how we actually have mapped all this into XML. So there is an existing XML schema available here. Okay, so this is the concept. Now let's try to find out how can we use, next slide please, how can we use this for things like EduRoam. We would need to have some distribution infrastructure at the sites. Probably doing this in a decentralized way, provide local service information, and also collect some remote service information and distribute it on demand. So one interesting question is, how can you do this? Do you always have to authenticate to the EduRoam infrastructure before you can get at this information? Or is there maybe something you can get before you authenticate it, so you can make your decision whether to authenticate in a meaningful way? So it may be useful to actually use the docking networks that are deployed in some parts of the EduRoam world to provide this information in the form of broadcasts, multicasts, to enable mobile devices to find out what's there. And then, of course, we can add things like voice over IP roaming, or even integrate third-party community systems like phone, SOFANet, or even the O-band we heard in the last talk to enhance the abilities of the device to actually find a wireless LAN while roaming. Next slide. Of course, one question is, if we actually are using broadcast, would the information fit? So we did some calculations in the paper and looked at what amount of information would be required to do this. And you can see that there is some need for efficiency here. So to provide the entire information for Germany, this only can be done at an interval of 900 seconds. So it will not exactly be instantaneous switching on a device after stepping out of the airplane and finding out what can be done in Germany. If you go to a more local environment, then the intervals actually can be smaller. So for Berlin, you can go down maybe to 120 seconds. And for a specific city area, for wireless LAN, you can go down to maybe 30 or 15 seconds. And I think that's a reasonable amount of time after stepping out of a plane before your device is fully informed of what's out there in the local environment you are now entering. But still, there needs to be some tuning done. We need to understand the intervals, the sending rates, and we need to work on the descriptions, on the separation of the descriptions into those parts that really need to be part of the broadcast, that really need to be known to everybody, and the refined parts that are then provided on demand. Next slide. So we actually did some measurements. I'm a little bit out of time, I think, so I'm going to skip this a little bit. Next slide, just to show you how we did this. So we loaded up data for a couple thousand hotspots and to our campus wireless LAN installation, and did some qualitative measurements. Next slide, please. Based on the Fluid Muppet implementation that we have. And of course, given that we are using multicast in wireless LANs, we have to live with packet losses. So the forward error correction based reliability of Fluid comes in very handy here. And next slide, please. Slide 30, please. Thank you. So you can see tuning the redundancies a little bit, we can change the utilization of the capacity we would need for sending this information. So this is not yet quite what we want in the end, of course. We don't want to spend 30% of our wireless LAN just to announce its presence and capabilities. But then we have configured our wireless LANs to use a multicast rate of 1 megabit per second, and that may be something that we want to change in our configurations. Essentially what this shows is that in principle what we are proposing is workable, and we need to put some more work into tuning the parameters. Next slide. So in summary, we think that network information services are pretty important to allow mobile devices to actually find the network that they want to use. As long as you're living in the environment of a single provider, that's maybe not that important, but if you think about an environment where you have many providers and the selection for a specific service becomes complex, these network information services can really help. And they can not just help in handover, that they can actually help in finding other services as well. And what we need to find out is how much information do we want to distribute, and which local services can be made available to roaming users. Okay, next slide. So thank you for listening, and in particular I'm thanking the people who made doing this presentation via video possible, and thank you for advancing the slides for me. This is a presentation that really was meant for being advanced by a clicker and not by a human, so I apologize for that, and now I'm looking for questions.
Yeah, first let's thank Carsten, the speaker. Other questions? comments, objections? Ah, there is one, Klaus. So I'm using this.
Klaas Wieringa, SurfNet. I don't have so much a question as a comment. I read the paper, I actually evaluated it, and I think it is a really very interesting approach, and I just want to encourage the authors of the paper to bring this work to TF Mobility, because I think we can learn a lot from it and we can get something really nice with it.
Well, I think I recognized Klaus' voice. Is that right?
Yeah.
Yep.
Yeah, thank you. We certainly are interested in carrying this work back into TF Mobility. I've been involved in TF Mobility in the past, and there is lots of synergy here, and we certainly want to make use of that synergy.
More questions? I don't see any hands, so let me put the last question. There are many other approaches being in concurrence with the Internet Media Guide, especially from the broadcasters, TV broadcasters and stuff like this. How do you see the chances of these Internet Media Guides becoming, let's say, the use standard?
Well, as a technology developer, that's always very hard to say, because in the end it's a decision that will be made in the boardrooms of some companies. But just looking at the technology, I would say that the chances are pretty good, because there are so many things that can be mapped into this framework. And there needs to be a way to combine the broadcast announcement world with the subscribe notify world, and that with the request reply world, the query response world. So I think it's good to have this framework, and we essentially will have to see how well it is being picked up, because there are always some incumbent old legacy schemes that we are competing with the electronic program guide mechanisms that are already out there, things like XML TV and so on. So it's really hard to say how wide the penetration of this technology will be. But I think it's good enough to actually use it in a number of cases.
Okay, we'll cross the fingers from Catania here and discuss this further on the conference dinner. We thank you again. And best wishes to Bremen, is that right?
Thank you, yes.
Bye-bye.
Bye-bye.
And now I can tell you something. We were crazy enough to make your video conference over the wireless connection. And it does work.
Great.
See you. Thank you again.
Thank you. Bye-bye.
Yeah, so ladies and gentlemen, this closes the session. Let's thank all the speakers again. This was, I believe, an excellent active session, and so we are ready for having some rest and then going to the dinner. See you there. Nicht nach Hause nehmen. Ja, richtig.
Cos'è, un ripostiglio? Adesso sto ripostiglio spacca, dai, sto buono.
Salve.
Buonasera.
Pronto?
Mi riceve?
Sì? Con... Paolo?
Io la sento.
Ok, un attimo, adesso fra un po' ci vedete anche, un attimo. Dovreste vedere la sala che si presenta in basso a destra. La vedete?
Sì.
Ok, perfetto. Potete mettere sull'identificativo della vostra macchina, magari vedo che è collegata a Roma, sarebbe possibile mettere come identificativo della macchina come ID tipo Uniroma 3, che così dopo viene visualizzato sul display per ogni partecipante.
Un identificativo, cioè dovrebbe essere taggato Uninapoli, se non sbaglio.
Ah, ok, allora non viene visualizzato, si vede che non viene preso, va bene.
E comunque questo è un'ETRA, quindi bisogna vedere, forse questo genere di informazioni sono proprietarie.
Ok, e per quello che riguardava il firewall poi avete rimosso i filtri?
No, noi non abbiamo problemi di filtro.
Ma perché io prima... No, questo è Roma.
No, è Napoli.
Pronto? Roma? Ah, ok, allora niente, scusami, non vedevo chi parlava. Allora un attimo, dopo allora provo io a fare un collegamento per provare a chiamarvi dal nostro sistema, così verifichiamo che funziona la chiamata in tutte e due le direzioni. Va bene?
Da Roma?
Salve Roma, ok, perfetto.
Ok.
Ok, sentiamo anche Roma. Ok, allora chiedo a Roma, avete tolto i filtri dal firewall?
Sì, diciamo che noi non li abbiamo provato a cercare, ma noi sembra che siamo
Firewall,
liberi.
non è che avete anche
Il problema
degli
era che a un certo
access
punto ho visto che la nostra stazione Polycom si è resettata e quindi si era spenta, l'ho dovuta spengere e riaccendere. Per me era un problema di questo tipo.
Even if I left the local microphone on. So there was a little bit.
Luca, mi senti?
Sì, ciao Paolo.
Ciao. Ma fallo cieco. Ma dove sei? Tu in sala regia?
Sì, adesso sto in sala regia dell'aula magna rettorato.
E stai parlando da dove? Dall'impianto di amplificazione?
No, sto parlando dal microfono della stazione.
Dal microfono della stazione, della Policom. Certo. Ma ancora lo fa questo lavoro che si spegne e si riaccende?
L'abbiamo dato di nuovo in giro.
No Paolo, l'ha fatto, cioè nel senso io alle 2:30, alle 2:15, quando abbiamo messo sul servizio, ho fatto la chiamata verso Catania, poi l'ho lasciata accesa, adesso quando sono risalito per l'appuntamento alle 5:30 l'ho trovata spenta.
L'hanno
Cioè
fatto
spenta
qui
nel senso che
l'abbiamo spento
si
noi.
è impallata perché la stazione era accesa però non c'era segnale video.
Hanno tolto da qui il collegamento, quindi lei probabilmente si è impallata perché non trova più il ritorno.
Ah, è possibile.
Io ho fatto l'hang up, però quando ho provato a richiamare non sono riuscita a fare il collegamento, ma non è che dovete accettare la chiamata in ingresso esplicitamente o il setup va su in automatico?
Io l'ho settata in automatico.
Allora c'è qualche problema, perché almeno
Possiamo fare la prova adesso? Mi sgancio?
Sì,
Mi chiamate voi?
Sì, vi sgancio e poi adesso vi chiamo io, che così verifichiamo se funziona bene anche la chiamata da parte nostra.
Ok, allora ci rivediamo fra poco.
E sganciamo anche Napoli, che così proviamo a vedere anche la chiamata verso Napoli, va bene? Napoli va bene?
Perfetto.
Ok, allora adesso vi sganciamo. Paolo, mi sganci tu? Sì, sì. Sì, no, cioè, sono già nei partecipanti. Funziona meglio.
Vedi che lui mi sta già guardando, ma di notte, di notte, proveremo di notte.
Proveremo di notte. Quanto hai detto? Quanti mega?
No, 30.
Da dove a dove?
Avevo provato su tutto back dove ci sono le 2.5 giga.
Va bene. Là va bene.
Stavo facendo una richiamata.
Là va bene. Altrove no. Se mi chiedete di farlo con l'università di Camerino, no, non se ne parla.
Vabbè, ma con loro avevamo provato su 155.
Ma dove sta? Allora,
dai,
là si può fare.
La prossima.
Là stanno attaccati a un perché tutto sommato.
La prossima
sono stati attaccati sul perché tutto sommato
è un 7005. Il nostro.
Il nostro. Però. No, è che siamo al limite come. Siamo al limite come Microsoft.
La prossima è la lezione